Hello wonderful person, this is Anton, and in today's video we're going to be imagining what would happen if you fell through a gas giant. Specifically, let's actually fall through Saturn, just like the Cassini mission back in 2017. So, let's just imagine that here you are working for NASA, orbiting Saturn, and suddenly something happens, and unfortunately your cable snaps, and you start losing orbital velocity, and then start falling into this beautiful gas giant. At which point you might actually start freaking out. Now let's actually find out what would happen as you go through these layers of gas giant stuff and what would actually end up happening at the end. And of course, back home on Earth, the NASA and whoever else is involved with the mission is probably freaking out, but they're curious to find out what actually happens to your body. Now, as you start falling through the upper atmosphere of Saturn, you'll actually realize that the gravity here is not that much stronger than on Earth, so your actual velocity will be very similar to the upper atmospheres of Earth, and you're going to be falling through some layers that might seem familiar but have different color. And these first layers are just going to be ammonia clouds, specifically white ammonia clouds, but your descent speed is going to be relatively large. You might be moving at speeds close to 1 km per second, yet views will be pretty spectacular. The temperature, however, is going to be pretty cold, so you may want to bring extra layers inside your suit, but it is going to be slowly warming up. About 15 minutes later, things will start changing, and you'll actually start experiencing slight darkness, and as you go deeper and deeper into the atmosphere, it's going to become darker and darker. Now a few minutes later, you're going to start seeing a second deck of clouds, and this is actually slightly different in composition. These are ammonium hydrosulfide and ammonium sulfide clouds, so they're actually going to be brown in color. And the air pressure at this point actually increases to above the air pressure even on the surface of Earth, so you're going to start slowing down quite dramatically because the gravity here is actually about the same as on Earth, but the atmospheric pressure increases with your fall. And right after you pass the second layer of clouds, things will get slightly or actually dramatically darker. You're going to actually barely see even your own hands now. And then a few minutes later, you're going to start reaching the third layer of clouds, and the pressure here is going to start dramatically increasing to 4, 5, 6, and almost 10 atmospheres. So you're going to actually feel quite squeezed if you didn't bring some sort of a pressurization device inside your suit. And as you're falling through these water clouds that look kind of similar to Earth, you actually start seeing a lot of interesting things, including lightning that is going to brighten your day a little bit, or possibly electrocute you and kill you right there. And with pressure being at least 5 atmospheres now, you actually might start experiencing what's known as the oxygen toxicity. This is actually a condition that starts occurring and can even kill you if you bring a normal air composition inside your suit. So you actually have to start changing the composition of your air that you breathe in order for you not to die from toxicity of oxygen. And now things get pretty dark and you start getting really compressed. But the thing is, since you're mostly water, only the air inside of you will get compressed. The rest of you will actually be fine. Now you start seeing a lot of lightning and thunder, and you probably start getting really scared because you're going to die pretty soon. And as you fall through, you actually start experiencing quite a lot of winds with speeds almost 200 meters per second or 720 kilometers per hour, and things become really dark. Now this is actually the part where the temperature might actually become comfortable, 23 degrees Celsius, basically room temperature, but as the time passes, after about half an hour, you're actually going to start getting in trouble as the temperature increases to almost 100 degrees Celsius, or the boiling temperature of water. More pressure, more darkness, very hot. And as things warm up, you realize that hydrogen no longer behaves as a gas and it becomes very liquidy. So you basically float through this hydrogen that becomes more and more hot. First 1000 degrees Celsius, when it actually starts glowing red and you finally start seeing things, and obviously die, but let's assume that your suit has some sort of protection. Then 5000 degrees Celsius, and basically it starts glowing kind of like a sun or a star. And then you reach 10,000 degrees Celsius, and this is at a depth of about 20,000 kilometers, where things become very unusual, very strange, and you start experiencing things like helium rain, for example, which is something that you don't see very often on Earth, or actually at all. And at this depth, obviously you're probably dead a long time, but we're assuming that you're still alive for some reason, you reach what's known as liquid metal hydrogen. Now this is essentially hydrogen behaving as a liquid metal, which is what's responsible for generating a tremendously powerful magnetosphere around all of the gas giants. And at this point, hydrogen starts acting as a kind of a supercritical material that is kind of liquid, kind of gas, and is same density as you, so you don't sink anymore. But let's just say you brought some lead shoes or some other material that allows you to sink even more, and so you actually go through the unusual liquid metal hydrogen and start sinking even more. Now this material will actually dissolve everything, including you and your suit, but we're imagining things, so we're going to imagine that you didn't get to dissolve in this unusual material and you keep sinking even lower. The temperatures here are ridiculous, as are pressures. The pressure is probably about 2 million atmospheres, and the temperature is over 10,000 degrees Celsius, and possibly even 11,000 degrees Celsius. But nothing stops us at this point. We keep sinking more and more for about 15,000 kilometers. And because this material is actually very dense, you're going to be following through this for many weeks, and at some point you're going to reach solid ground. Now this is actually made out of rock, exotic ices, metals, and a combination of materials we probably can't even imagine because we've never seen them except for some extreme cases in the lab. You're basically standing on what might be considered to be the core of a gas giant, and you kind of start slowly walking away, hoping one day to return to Earth, but in reality you're long dead because, well, there's no way you can survive in these conditions.
Hello wonderful person, this is Anton, and today we're going to be talking about one of the more mysterious geometric objects in the solar system, this right here, the so-called hexagon of Saturn. And it looks like we may have finally solved its mystery, the mystery of its creation, at least to some extent. There are still a lot of questions about how this unusual shape is formed and what exactly is happening underneath it, but we're getting much closer to answering what's going on here. So the date is 1981 and the Voyager 2 probe, is passing Saturn right now, to use it as a kind of a slingshot maneuver. As it passed above the North Pole of Saturn, it noticed something really unusual, something we've never really seen before. The unusual shape that's now known as the Saturns Hexagon. A very unusual and very peculiar hexagonal cloud shape that's actually extremely stable. It doesn't really change its shape very much. It also does not move across Saturn almost at all, and it does seem to be almost like an actual stable shape, as if it was made out of something solid. And since the original discovery in 1981, it was then extensively studied and obviously revisited by the Cassini probe starting in 2006 until its demise a few years ago. But even today we still have trouble explaining what exactly is happening here because there are no other similar shapes pretty much anywhere in the solar system. Now just to give you a size perspective here, this is actually about 2,000 kilometers bigger than planet Earth. So this whole spot could technically hold our planet on the inside. It's about 14,500 kilometers wide, or about 9,000 miles wide, and it's essentially the biggest, most unusual shape we have in the solar system. And although it's not as big as the famous Great Red Spot on Jupiter, the Great Spot at least moves in a very sort of explainable way. It does seem to be a very large storm. The hexagon obviously has some motion on the inside too, but the actual shape itself does not move very much. The stuff on the inside moves and the stuff on the outside does. The shape stays stable, which is why even today it's still one of the bigger mysteries of the solar system. But because its rotation takes it exactly the same time as the rotation of Saturn, here the winds move at about 320 km per hour and the single rotation takes approximately 10 hours and 40 minutes to complete, which is basically the same time it takes for Saturn to rotate once as well. It does mean that whatever is creating this unusual shape is probably related to the upper atmosphere of Saturn, or possibly mid-regions of Saturn, not so much the lower regions where things behave extremely different from what they do on the outside. But interestingly, when the Cassini mission got to Saturn, it realized that this shape actually changed its color. Specifically, during the mission itself, between 2013 and 2017, the hexagon changed its color from mostly blue to somewhat more golden, and that's something that we couldn't really explain and still can't explain even today. It most likely has something to do with seasonal changes, but we're not really sure what's causing these changes just yet. But more importantly, the southern pole of Saturn does not have this shape. There is a vortex in the middle, the one that you can kind of see right here, but it's not a hexagonal or really any geometric shape, and this was confirmed by Hubble and really kind of created the mystery here. Why is it that this is only formed on the northern side, and what exactly is causing this unusual shape to form? Now, the original explanation was related to the changes in speed as you go deeper and deeper into Saturn. Some of the experiments here on Earth, by using water tanks, were able to create something similar when the water was moving, for example, faster on top, slower on the bottom, and even slower the lower you go. But this wasn't a perfect explanation because these shapes were not very stable and would change with time, which is what we don't really see with the hexagon. And so a completely new model was presented very recently, and it does do a pretty good job explaining how certain geometric shapes can actually form. It didn't form a hexagon though, it actually formed triangles. And the scientists behind this paper used very complex simulations to try to understand how these complex shapes can form if you have layers of different complexity in an atmosphere like the one in Saturn, for example. When their model was completed, they were able to generate something like this. And as you can see here, if you were to look at the outskirts of this, it does actually form a somewhat triangular shape, which in some sense can explain how these hexagons can form as well. The idea in their study is that the activity happens very deep in the atmosphere of Saturn, where the pressures are like over 100,000 atmospheres, basically 100,000 times the atmosphere pressure we have here on the planet. And when hydrogen reaches these atmospheres, it actually does not behave like gas anymore. It actually starts acting like liquid. And because the temperatures in these regions are also very hot, it essentially becomes this really hot liquid that swirls around, very similar to an extremely large and an extremely massive water vortex that sometimes form in the oceans here on Earth. But in this case, these vortices, as they move around the planet and also as they interact with the vortices nearby, they form these regions right in between them that start resembling various geometric shapes. In this case, it's a triangle, but the scientists behind this paper suggested that if, for example, 6 different storms like this interacted with one another, they would produce a hexagon. And so in this case, this activity deep inside the planet, approximately 10,000 kilometers inside the atmosphere, as it starts affecting the regions and the layers above it, begins producing these very unique, very strange geometric shapes. And the scientists in this paper also mentioned that something similar was actually discovered by the Cassini mission as it was plunging into the atmosphere of Saturn. Right before its final transmissions, when it disappeared in the atmosphere of Saturn, it was able to transmit data suggesting that various storms like the ones we see on the surface actually propagate really deep into the atmosphere of Saturn itself. In other words, what we see on the surface, these shapes here, actually extend really deep into Saturn, and their structure vertically is just as important as their structure on the surface. And these storms in the depths of Saturn are most likely created by all kinds of interactions, convection interactions, between the very cold atmosphere on top and extremely hot atmospheric and liquid layer on the bottom. As you can see here, the actual activity inside Saturn is a lot more dramatic and a lot more active than anything on the surface. And most of this is at really high temperatures and with these really highly pressurized molecules of hydrogen that become liquid. Now, this is not metallic hydrogen yet though. Metallic hydrogen, which actually most likely creates the magnetosphere of Saturn, is much deeper than these layers. So metallic hydrogen and its creation of magnetosphere happens at even lower layers and might also actually be responsible for certain storms we see on the surface. But at the moment, this model is still relatively simple and doesn't explain everything. For example, this only captures about 1/10 of the entire surface of Saturn, and it doesn't really deal with the three-dimensional aspects of the entire planet. At the same time, it obviously does not create hexagons, it creates triangles. So future studies and future models might actually finally explain how all of this sort of interacts together to create this unusual shape, and also why this shape doesn't seem to appear on the opposite side of Saturn. The opposite side just seems to have a vortex, not so much any geometry at all. But for now it does seem like whatever is causing this is happening deep within the planet and is most likely caused by the interaction of various very powerful storms that are forcing the formation of these unusual shapes by interacting with adjacent storms as they travel across the planet. In other words, this is basically kind of like an edge formed by various storms pressing against each other, and because of the way they travel across the planet, they seem to form this unusual geometric shape. But the question of why this storm is here and why other planets don't seem to have it is obviously still a mystery. We still don't really know much about Saturn, and we don't even know technically what's inside of Saturn, but we kind of can guess based on what it's made out of and how gases react to higher pressure and higher temperature. Other than that, we are still really guessing and are not really even sure if these planets have a much more solid, much more Earth-like core on the inside, or if they're basically just hydrogen compressed all the way until it becomes a very solid chunk. But since the Cassini mission is now finished, and since we don't really have any new plans for any exciting missions to Saturn in the next few decades, that's, I guess, it for now. We're not going to learn much more about the storm until we can create better simulations. Hello wonderful person, this is Anton, and today we're going to be talking about my favorite moon in the solar system, Titan. This right here is the Huygens mission, the mission that actually landed on Titan and was even able to transmit very beautiful footage that you're about to see right here. This is an actual footage that NASA was able to get from Titan, showing us what this unusual moon looks like. Today we're going to be talking about several different things we've discovered about Titan only in the last few months or so. And some of these discoveries redefine our understanding of not only Titan itself, but also its creation story, its unusual volcanism and potentially other geological activities, and also its very strange yet very active climatic conditions, some of which seem to be seasonal. So here are these images from the landing of Huygens on Titan, and they are kind of mind-blowing when you think about it. All of this is slightly processed because there's actually almost no light on Titan, so it's very difficult to see anything. As a matter of fact, the surface of Titan receives only a fraction of 1% of the entire light we receive here on Earth. So this is a really dark, really cold place. Nevertheless, this image here represents a huge achievement for humanity. And since then, we haven't really stopped learning more about this unusual moon, with most of these discoveries coming from the data that was collected by the beautiful Cassini itself as it orbited around Saturn and approached Titan many times during its very long mission. And a lot of these new discoveries actually tell us a really interesting story about Titan and also sort of redefine our understanding of this moon and its creation as well. So first of all, the biggest discovery was in regards to the Titan's unusual migration patterns around Saturn. Currently, Titan is located right here around 1.2 million kilometers or about 750,000 miles away from Saturn. That's close to about 3 to 4 times the distance to where Moon is around planet Earth. But the thing is, we've always believed that this particular moon was actually created in this vicinity, mostly because we thought that that's how very large moons of these gas giants are created. At the same time, we also thought that for the most part Titan isn't really moving anywhere. It's basically sort of stuck there around 1.2 million kilometers away and is sort of slowly, very slowly drifting away from Saturn. We estimated this drift to be about 0.1 centimeters per year, which is actually very low. But that is not what we've recently discovered. One of the most recent discoveries was actually kind of mind-blowing, because turns out that according to the scientists behind this paper right here, Titan is migrating away from Saturn about 100 times faster, at a speed of about 11 centimeters per year, which is also about 3 to 4 times higher than the moon's migration from planet Earth. And the reasons for this migration is not the same as moon around Earth either. It's not really related to tidal locking or tidal effects as much. It's actually related to the way that Titan itself influences Saturn, which unlike Earth is not made out of actual rock. It's obviously made out of gas. And as the Titan influences this gas, Titan's orbit around Saturn causes the planet to actually oscillate just slightly. Here I'm really sort of exaggerating this, but in reality these oscillations are very minuscule, and these oscillations which are caused by the gravitational interaction of Titan and Saturn, do so at a very specific frequency that causes Titan to slowly move away at that speed of 11 centimeters per year. Now the explanation here is somewhat difficult, but in reality it's actually sort of comparable to the way that a person can gain height on a swing by swinging their legs in a very specific manner using the same frequency. So this is kind of what Titan does to Saturn and why it's able to gain these 11 centimeters per year. And the thing is, we know for a fact that this is how fast it's now moving away from Saturn based on two very specific observations. The first one was by using astrometry, and that's when Titan passes in front of a star and we can then usually measure a lot of different parameters very accurately. And the other one was by using the data from Cassini mission and using radiometry data that was collected over several years. Both of them seem to actually produce exactly the same speed for the motion of Titan, suggesting that it is moving away from Saturn after all, and really fast. And what this implies is that Saturn and possibly even other moons, including of course the rings of Saturn, were actually created in a much more dynamic way in the early solar system, suggesting that first of all the moons were much closer to Saturn, possibly even within the actual rings themselves, and second of all that their formation may have actually been very different from what we originally thought. And this could be very similar to what's happening around Jupiter as well, and of course other gas giants in the solar system. In other words, we still have a lot to learn about the formation of this unusual moon and how it acquired its unusual properties. Which kind of brings me to the next discovery here, the unusual specular reflections, or basically mirror reflections, that were coming from the surface of Titan and that we thought were actual lakes and possibly other bodies of liquid. And although we know that the surface of Titan does have lakes and other bodies of liquid, we also know that most of them seem to be located in the polar regions of this object. Here's actually one of the bigger objects in the southern pole, and this one is known as Lacos Ontario, or basically Lake Ontario, kind of similar to the one we have on Earth as well. But the thing is, these reflections were coming from the equator, and we know that the equator for the most part is really dry. Most of the region here is essentially dunes and would resemble the desert here on planet Earth, except that of course it's not really sand. It's the same kind of dunes we find in places like Antarctica. It's water ice. As a matter of fact, all of these solid structures here are essentially water ice of different types. And that's what forms the hard surface on Titan, whereas the liquids are methane and ethane. But nevertheless, we seem to be seeing these reflections coming from the equator, and the scientists finally figured out what's causing it. It seems to be a sign of lake beds, or basically what used to be lakes is now just the empty spot where the lake used to be. Now this is really important because this may have actually happened relatively recently, and this also indicates that Titan does have very active hydrosphere and very active liquid cycle. And this paper goes in a lot of detail trying to describe how this liquid may have migrated from the equator up to the polar regions where we now see quite a lot of different liquid as well. In other words, this could be actually a seasonal change. It's very possible that once in a while the lakes here disappear and all of this liquid migrates to the polar regions, whereas occasionally these lakes might also reappear and the entire moon might actually be covered in a lot more liquid than it currently is. Right now we obviously don't really know when these cycles happen and how all of this is regulated, but the unusual observations do suggest that the climate and the seasonal changes on Titan are extremely complex, possibly even more complex than on our own planet Earth. And since this is the only other object that actually has any liquid on the surface except for planet Earth in the solar system, this obviously means that we are extremely interested in studying Titan in more detail to try to understand these cycles and try to understand these seasonal changes as well. And this could also be related to another mystery of the so-called Titan-wide methane cycle, where the methane itself seems to circulate in very unusual patterns and seems to produce these unusual methane formations all over the planet, and some of them have even been explained as the potential sign of life on this unusual moon. We don't really know what causes it, and we don't really know what's going on Titan, but if all of this is caused by life, then that's even more exciting and even more reason for us to go and explore this moon and possibly even make a colony or two. And the last exciting discovery coming from Titan is actually in regards to what seems to be active volcanism, or at least signs of recent volcanoes, which seem to be extremely similar to the craters we find here on Earth as well. With the main difference, of course, being that instead of actual rock, we have water ice, and instead of magma, we have liquid water. Which means that these are so-called cryovolcanoes, and there seem to be a lot of them all across the northern part of Titan, specifically on the northern pole, where a lot of the lakes are located as well, which is a strange coincidence and also might indicate that the northern part of Titan is a lot more active both geologically and also hydrologically, suggesting that it possesses a lot of different activity and might actually have a lot more mysteries for us to discover. But all of this right now suggests that Titan is a lot more active and a lot more dynamic and ever-changing than we initially thought. At the same time, it also seems to be even more similar to planet Earth in terms of the activities present on the surface, despite obvious differences. It's much colder, it's much smaller, it's a lot less massive, yet it possesses very thick atmosphere, it has a liquid cycle, it has geological activity and also liquid activity on the surface. In that sense, it's a very interesting object, and honestly, it really should be our priority for the search for extraterrestrial life. Hello wonderful person, this is Anton, and today we're going to be talking about one of the most beautiful moons in our solar system, Enceladus, the moon of Saturn. And we're going to talk about the discovery of how we believe the stripes of Enceladus were formed. Unlike other moons in our solar system, Enceladus really stands apart, mostly because of these unusual stripes that form on the surface as a result of some sort of an activity we didn't really understand before. Here's a composite shot taken by Cassini mission when it was still around Saturn, and this is what Enceladus really looks like if you were to look at it from space, from orbit. It has these beautiful but somewhat unusual looking blue stripes all across the surface, and we didn't really know how to explain their formation or why other moons don't seem to have the same. You know, if you were to zoom in, you would even notice that there is almost like a pattern to them, as if something unusual caused them to form in the way that they formed. And it just so happens that we may have solved their mystery. But before we talk about this, let's compare Enceladus to some of the other moons. And specifically the bigger moons in the solar system, because unlike Enceladus that's right here, you'll notice that other moons are much larger in size and obviously have a lot more mass. Even Saturn's own Titan is dramatically bigger than Enceladus. And if we were to try to visualize size difference here, as you can see, Enceladus is basically really tiny. Notice how neither one of these other moons, including the Ganymede that does have some stripes, but not the same types of stripes, have these unusual formations similar to what you see here. And size and mass is one of the possible answers to why we're not seeing this on other moons in the solar system. The closest we have is of course Europa, the moon of Jupiter, and here you will find certain stripes, but first of all they're not really blue, and second of all they're not actually formed in the same way, neither are they ordered similarly to the ones on Enceladus. Here the stripes seem to be all over the place, they don't seem to have any predictable pattern. However, these stripes do have a pattern and only seem to be concentrated in the southern part of the moon. And all of these observations create a somewhat interesting story. So first of all, these stripes are more or less parallel. The distance between them is roughly around 35 kilometers on average, and at the same time they all seem to possess very similar structure. The stripes on Europa are more or less hectic, they don't seem to have any pattern and do not possess the same structure. On top of this, Enceladus has this really unusual feature we were able to witness with the Cassini mission. Let's use NASA's eyes on the solar system to try to discover what all of this looks like. So here, if we look at the moon of Enceladus, you'll notice that right there in the southern part, where those unusual formations are, we also have these geysers. That's basically where we were able to find really large emissions of water and also organic material coming from within the moon. And all of this seems to suggest to us that not only does Enceladus have liquid water on the inside, it's also extremely active and might even have conditions possibly friendly to life, alien life. This also produces one of the rings of Saturn. The E ring is produced through these emissions. And this altogether brings a very interesting and very unusual mystery. How did all of this form? And so the scientists behind the paper, that you can find it in the description below, may have finally solved this mystery. So first of all, these stripes are definitely formed because of the tidal interactions with Saturn, and because of various gravitational interactions with both Saturn and the moons around Saturn. So here, similarly to how the moon Io, the moon of Jupiter, seems to have volcanic eruptions because of the tidal interactions, same effects are able to produce not only the emissions on Enceladus, but also are responsible for cracking the ice here. And these cracks in the ice are essentially what's forming these unusual stripes. But why is it only on the southern side? Well, according to the scientists, this was literally by accident. It could have been the northern side, but it's very likely that for some reason the southern side had slightly thinner ice, and so it cracked first, and since then all of the energy transfer has been occurring on that side. In other words, sometimes in the past, very likely right after the formation of the solar system, the ice here gave in and created these unusual formations. The northern side doesn't seem to be affected as much, probably because of the slightly different ice formation in the north, allowing it to be a little bit more stable. But what's interesting is the way that these stripes were formed and how they were generated in such an unusual shape. The scientists believe that all of this happened very methodically and started with one stripe specifically. The stripe they refer to as Baghdad Sulcus. All of the stripes here are named after places in the 1001 Nights, which are also known as the Arabian Nights, with the most popular story being the Aladdin. So that's why we have these names here. And once this crack formed, which was about 135 kilometers in length, it started to create a very interesting effect, which I described in their paper in a little bit more detail. In a nutshell, once the first fracture appeared, it started to deposit a lot of ice on the sides, mostly because of these emissions that we're observing today as well. And these emissions created enough ice load here to create even more pressure on the ice close to the fracture. And eventually this literally caused the other sides of the fracture to snap and create more fractures. And eventually this caused these two fractures to also snap, creating their own eruptions and their own large formations. And because the deposits on both sides were more or less equal, that's why the distance here is also more or less equal to about 35 kilometers. And this obviously led to other eruptions and other formations of more fractures, eventually creating this beautiful surface, very unique in the solar system, that we would not be able to find anywhere else. And one of the main reasons why it only happened on Enceladus is very likely because its mass and its size obviously are just not large enough to prevent the ice from collapsing in this way and also the water from escaping. If this moon, if this object was much larger, like for example size of Europa or Ganymede, it would not look the same way at all. It would more likely look like Europa or Ganymede. The fractures on which are very hectic, they don't seem to have any emissions, and neither one of them have these beautiful geysers. So this is why we believe Enceladus is so unique. And also because of the materials we've seen coming out of those geysers, we believe today that it's very likely going to be one of the prime places for us to find alien bacterial life, or possibly even more complex extraterrestrial life. And in case you were wondering about the actual structure, so the ice here is several kilometers thick, and then we believe that's where the liquid ocean is. And it also has a somewhat large rocky core, where there's very likely a lot of underwater volcanic activity, similar to what we have here on Earth as well. And at least here on Earth, these underwater volcanic spots are usually some of the most prolific places to find life, which is of course why we believe Enceladus might be hiding some life as well. But because there are no current missions being planned to go to Enceladus, we're probably not going to find out for the next few decades at least. Unless, of course, we somehow see an actual bacterial life being shot out of these vents and discover some unusual bacteria hiding in these E-rings of Saturn. It could happen, you never know. And so just to summarize what we've learned from the study, first of all, so the stripes occurred in the south mostly as a kind of an accident, probably because the southern part was a little bit weaker. The formation of these stripes relates to the tidal effect and to the gravitational effects of Saturn and the moons nearby. And the reason they still exist and they look like this is actually mostly because Enceladus is just not massive enough to stop the formation of these stripes from occurring. In other words, it's kind of like having Saturn prevent the moon from healing its own wounds, and because the moon is so small, it's just unable to do so quickly, which is why the ice here never really gets to close completely, and why we get these unusual water formations in between ice. And I guess the most interesting discovery here is why these stripes are so orderly, and the answer to that lies in the way that we think the first stripe caused the other stripes to form because of the loading of the ice once the first of these stripes started to produce enough geysers to fill the ice nearby.
Hello wonderful person, this is Anton and this is Saturn, that according to NASA apparently didn't always look like this. Which is almost, actually, no, exactly the opposite of what I said in the video that I made about a year ago, where I swore by it, saying that this is like what Saturn always looked like and it never changed. Thanks NASA, now I have to erase this video. Actually no, how about I make a new video where I basically pretend that like the other video never happened. That's exactly what I'm going to do. Hello wonderful person, this is going to be a video that is going to explain to you what NASA just discovered about these tremendously beautiful rings of Saturn. And it also suggests that other planets in our solar system also look completely different from how they look now. Which is actually absolutely awesome, because that part I speculated about before. Anywho, so let's talk about this and let's see what actually is happening with these rings. Or, in other words, why NASA is now absolutely convinced that we're living in a sort of the perfect time frame to see these beautiful formations. According to NASA, these rings have only been here for about 100 million years. So in other words, when dinosaurs were around, most of them didn't see them with their tiny little binocular eyes or tiny dinosaur telescopes that they had. Okay, that kind of de-escalated pretty. Okay, that humor just killed it. Should I start the video over? Nope, I'm gonna continue. So on this note, basically what NASA is saying that in the next 300 million years, these rings will disappear. Let's see what's actually happening there, because that's totally fascinating and absolutely incredible. None of us actually knew what's happening with the rings until this really recent study using the Keck telescope from Hawaii that studied the interaction between NASA's ring particles and the magnetosphere of Saturn. As you may know, Saturn has the second strongest magnetosphere in our solar system after the beautiful Jupiter, and this magnetosphere is actually destroying the rings piece by piece. Now, they actually refer to this particular phenomenon as ring rain, and it sounds super awesome. It's actually a pretty good name for a rock band if you're thinking of starting one, but what it refers to is literally a ring of rings. It's coming from the rings, and so what's happening here is that the radiation from the sun and also the micrometeorites supercharge the various particles, specifically the water particles, and they turn them into charged pieces of, well, water. And these pieces, these tiny little particles, start interacting with the magnetosphere of Saturn and then slowly fall along the magnetic lines and then create this beautiful, slightly radioactive rain that falls onto the surface in two regions. There's one actually that's going to show in a few seconds right here in the north, and one that's right here in the south. And they actually form these beautiful formations, these beautiful rings that are actually visible on Saturn. In other words, the interaction between the solar radiation, the micrometeorites, and of course the magnetosphere of the planet itself are forming these very unusual rain-like, I guess you can call them structures. Although of course this is not a true rain, it's more of a constant deposit of water molecules and essentially other ices that are bombarding the planet in these two regions. And because it's not actually dropping onto the planet but is deposited onto it, it probably would not be very easily visible even if you were right there. But the amount of stuff that's falling onto the planet means that all of these rings, for the most part, at least the actual ices, will completely disappear in about 300 million years. In other words, if you wanted to imagine what this planet will look like in about 300 million years, all you have to do is go to Jupiter or Neptune or Uranus.
because this is probably what it's going to look like in about 300 million years. And now, all three other planets, Jupiter, Neptune, and Uranus, do also have rings, but they're very, very small and for the most part have a completely different composition. The video that I made a year ago explaining why the rings of these planets are different, and that was actually the previous assumption, is that they were formed by a different type of an object. We actually thought that Jupiter, Uranus, and Neptune had some kind of a rocky-like object that passed by very close and then created these rings that I'm going to try to locate by looking against the sun here. And there they are. You can kind of see them right above my head. There's like a tiny ring formation, and these are actually not formed from ice. These are formed from rocky and metallic components. And so we actually originally thought that this is because it was formed from a different object. Now, because of this new research, this hypothesis is out of the window. We now are almost certain that they all had these large ring formations similar to Saturn. In other words, if we were to add all 4 planets to Universe Sandbox right here, and to give all 4 of them Saturn-like rings, it's quite possible that this is actually what all of them looked like several 100 million years ago. So all 4 objects probably had very icy rings. Maybe some were bigger than others. Maybe even Saturn did have the biggest rings. But for the most part, they disappeared with time because of this interaction between solar radiation, micrometeorites, and the magnetosphere of those planets. We know that Jupiter has the highest magnetosphere and also is exposed to way more radiation and possibly even more micrometeorites than Saturn. So it's sort of logical to assume that maybe, just maybe, Jupiter's rings were bigger, but it also depends on the kind of object that passed by to create those rings. We still think that this is how those rings were created, by essentially a relatively large asteroid or even some kind of a dwarf planet passing close to the actual planet and essentially being shredded apart and turning into rings. Let's see if this works with Pluto, and I think I may have missed. Yep, it's gonna go inside. There we go. That didn't work. But if we were to cheat a little bit and put it in a close orbit with Jupiter, it would actually start falling apart and create these beautiful rings that we now are going to have orbiting around the planet. So the chances for all 4 of these objects to actually have these large rings that Saturn has right now is very high. We definitely have to do more studies and find out what sort of rings all 4 objects had, but it would be very difficult for us to actually estimate the true size of these rings, because we don't have enough information about the objects that were captured or the amount of material that was actually lost to these various effects. And so here is what Jupiter may have looked like, and this is actually with a collision from another object, but you can see that its rings are much larger than they are today. And honestly, this is actually probably one of the most exciting discoveries of 2018, on par with some of the bigger discoveries of, well, the decade actually. It's really interesting how we were able to identify how these rings are disappearing and how it's very likely that this is actually what happened with the other planets as well. Now, whether it happened with our planet Earth and other terrestrial planets, that's another story. But because we have no evidence of either one of those planets ever having rings, we can't really say for sure just yet. Anyway, let's find out what NASA discovers about this unusual phenomenon in the next few years, and maybe, just maybe, we'll be able to explain the solar system even better. Hello wonderful person, this is Anton, and in this video we're going to be answering a question that was posed by one of the wonderful Patreons I have. And this is from a person named Ralph, who was wondering, so okay, hypothetically, if our solar system's habitable zone has expanded further and further to the area where Saturn and Jupiter are, or even further than that, would these gas giants, like Jupiter that you see in the back there, evaporate because, you know, they're gas giants? And would objects like Europa, Ganymede, Titan, and so on, would they actually turn into planetary objects? Or in other words, planets? And I think to try to simulate this at first, we can imagine that one day this actually is going to happen, because our sun one day will start turning into what's known as a red giant. Its mass will remain the same for the most part. It will actually even decrease a little bit, but it's going to start growing because it's going to run out of hydrogen and helium, and the forces on the inside will start making it grow in size. So at some point, the actual habitable zone that you see in green will reach Saturn and Jupiter, but then we'll also go further and further. Our sun is going to get so big that it's going to first swallow Mercury, then it's going to swallow Venus, and then possibly even Earth. Mars may survive, but we're not really sure yet. At that point though, the habitable zone is going to be really far away, probably past Pluto. The estimates right now suggest distances of about 40 to 70 astronomical units, so objects in this vicinity, for example, all of these dwarf planets like Eris and Sedna, potentially might turn quite habitable. They'll probably become somewhat habitable looking water worlds with quite a lot of liquid water on the surface. But that's not really what we're talking about. What will happen to gas giants? What's going to happen to all of the objects orbiting them as well? Well, let's start with Saturn. So the thing about gas giants is that they've already collected all of this material, they've already collected all of the gases and all of the so-called ices like water and methane, so they're not going to go anywhere. These objects are not going to suddenly evaporate and disappear. And that's because they've already collected so much mass that they can easily hold on to all of the hydrogen, helium and so on without really any problems. So even being so close to the actual sun and being illuminated by so much extra radiation will not really change their mass that much. They might increase evaporation a little bit, but they're not going to suddenly disappear or possibly disappear at all. They will, however, turn much hotter. So the estimate for example, Saturn right now is approximately 300 degrees Celsius, so it's going to become what's known as a hot Jupiter. It's a type of a planet that we've discovered in a lot of different star systems, where depending on the distance to the parent star, the actual planet becomes really hot, but it doesn't really disappear. Some of them do come really close to the parent star, like for example, let's take Jupiter, that's even closer and whose temperature right now is close to about 500 degrees Celsius, and then place it even closer. Let's place it at a distance of about 1.5 astronomical units so that its temperature increases even more. It's not going to start kind of burning and will start losing more material, but still not enough to disappear anytime soon. Many of these planets actually do eventually disappear and leave behind the scorched cores, the actual hard core that's inside the planet, if they have one. And these are often known as Chtonian planets. I've made a few videos about this concept in one of the previous videos that you can probably find somewhere above my head right now. But for the most part, they actually still don't really change that much, especially if these objects are really massive. They can easily hold on to hydrogen and helium, and the sun itself will not really affect them that much, but it will change what's happening on the surface. So one major change that both Saturn and Jupiter will have is that their atmospheric conditions will start being even more extreme. And although currently it already seems to have quite a lot of storms and all kinds of hurricane-looking conditions on the surface, it's going to increase dramatically. Like, this whole planet is going to be covered with tremendous amount of winds and all kinds of wind-related activity, and the actual speed of the atmosphere may increase dramatically as well. The cloud patterns will also change dramatically. We don't really know how, but we know that it's going to be very different because it's going to be much hotter now. But one of the biggest sort of changes is going to be related to the sudden increase in all sorts of charged particles that are going to be hitting this planet. And the way that it's going to reflect is by quite dramatically increasing the size and the power of the aurora effects that are present in the atmosphere of both Saturn and Jupiter. So these are going to be really extreme. The entire planet will probably be covered in these effects, and they will be visible from really far away. And this is all because the sun itself will become dramatically more active. It's going to have a lot of so-called coronal mass ejections that are going to be so powerful that the planets will probably just be lit up with all sorts of colors coming from those aurora. Now, because we currently don't have anything like this in our solar system, we can't even imagine how all of this will look like. because right now the most powerful of these aurora are technically around Jupiter, and Jupiter is still pretty far away from the Sun. But luckily Space Engine allows us to recreate this a little bit, and for all we know, maybe this is kind of what it's going to look like for at least one of these planets. Although it's possible that the extra radiation coming from the Sun might somehow disrupt the composition of the upper atmosphere, for the most part, the planet itself might not really change that much, although the color of the planet and the appearance of the planet will probably change quite dramatically. Now, what about moons of these objects, specifically moons of Saturn and Jupiter? Well, every moon that's currently made out of ice will obviously melt and lose a lot of this water over time because they're not going to have as much protection from the solar activity. And so even though technically for at least a few million years Titan will probably have liquid water, at some point even all of this will eventually evaporate, leaving behind an empty shell, possibly a tiny rock actually. And this is because, well, first of all, the temperatures here are going to be really high. Right now the temperature is showing at 300 degrees Celsius. This will definitely evaporate all of the water and all of the other gases here, and because it's technically going to be kind of like a small gas object, all of this gas will eventually escape and either combine with the parent planet, in this case of course the parent being Saturn, or it's possible that it's going to escape into the outer solar system and, well, nothing else will remain here, except for whatever rocky substance it might contain on the inside. We don't really know if it has any core, but if it does, it's going to stay behind as a kind of a tiny reminder of what used to be here. All of the other objects will have very similar fate, and so the planet Saturn will probably lose most of its moons because a lot of the moons here are ice-based. And none of them will turn into planets because it's going to be really hot here. However, with objects like Neptune and Uranus, things might get a little bit more interesting, specifically in Neptune because it's the farthest planet here. First of all, neither of these objects will be affected in pretty much any way, they're just too far away from the Sun, even though it's so gigantic now. But technically speaking, the moon Triton here would be very interesting because it might potentially become a very interesting habitable water world. However, the problem with Triton is that because it's currently orbiting in such a weird way, it's actually slowly approaching the planet. And by that time, it will most likely collide with Neptune. It will probably not exist anymore. So if somehow it manages to survive in about 5 billion years from now, it might turn into a relatively comfortable looking water world with potentially even some atmosphere. But due to the fact that it's way smaller than even our moon, and also because it's most likely similar in composition to Pluto, so it's essentially all ices, it's not going to have any surface to stand on, so it's going to be just a liquid water world. But all of the other objects here may kind of still stay in the same place and not really disappear anywhere because they're just too far away from the Sun. It's not really going to affect them as much. And neither Neptune nor Uranus are going to experience any major changes. So all in all, it's going to be a very different solar system from what we know today, and this particular period will probably last for just under 1 billion years. And after this, well, that's going to be the end of most of life in the solar system if it still exists here. And that's because our Sun is going to release all of this mass here, well, most of the mass, and create a beautiful phenomenon known as Planetary Nebula. This is going to be our Sun. It's going to be a white dwarf, the core of our star in the middle, and the rest of the stuff is going to be the leftover star material. And all of this material, as it escapes the solar system, is going to, well, literally scorch our planets, probably stripping them of everything, and leaving very little behind. Now, we don't really know how powerful it's going to be and if there's going to be anything left, but life cannot possibly survive these events. It's going to be very difficult. Unless, of course, we advance to the point where we can actually control this and somehow avoid this. And following this, that's all that's going to be left. The white dwarf known as the Sun, with a few leftover materials, like for example, these rings that used to be planets, used to be actual objects, but now are just the debris and the leftovers from what used to be. So that's going to be the end of our solar system, and that's based on the fact that we've observed these around other white dwarfs out there in our galaxy. And obviously we don't know if all of the stars follow the same sort of path, and if they all end up with the ring system, and if they all end up losing all of their planets, but so far that's kind of what we've seen. And although there might be some other leftovers, like tiny objects that resemble planets, all of the planets that we have today are probably going to be gone. Hello wonderful person, this is Anton, and welcome to the mysterious Titan, the moon of Saturn. In this video we're going to be talking about an amazing announcement coming from NASA that they have now confirmed the incredible mission to Titan that's going to start in 2026, and this time we're taking a very interesting helicopter-like drone there. Now if you've been on the channel long enough, you know that Titan is literally my most favorite object in the solar system, except of course for our own planet Earth. And that's because it is actually very Earth-like in many different ways. It is most likely one of the most Earth-like objects out there in the solar system, and would be one of the easiest to settle on and to colonize. And that's because, first of all, it has an actual atmosphere that's even thicker than the one here on Earth. In other words, here you don't have to worry about pressure, because there's quite a lot of it on the surface. And underneath all of this atmosphere, there is an actual liquid cycle with rain, with evaporation, with actual weather effects and all sorts of Earth-like conditions. The only problem, of course, is that it's kind of cold here. As a matter of fact, the average daily temperature on the surface of Titan is roughly around minus 180 degrees Celsius or minus 290 Fahrenheit. So yeah, it's chilly. Let's just say that you're not going to be able to walk around without some serious protection. But nevertheless though, it is one of the most exciting objects for us to explore because, first of all, we've already seen what the surface looks like. We've landed here with the Huygens probe from the Cassini mission, and back then we were able to take an actual video of what the atmosphere looks like, what the actual surface looks like, and all of it really impressed the scientists. So for the longest time since then, we've been trying to get back here because this world looks absolutely incredible. So here's the footage from the Huygens mission, and here you can actually see how all of this looks like in real life. These are actual photos taken by the mission. This is not a simulation. So this world is absolutely incredible, very, very intriguing, and most importantly has quite a lot of similar molecules to Earth. There's a lot of organic molecules here, there's a lot of methane and ethane, and a lot of molecules that are normally needed for life to evolve. So in a sense, this world may represent what Earth may have been like billions and billions of years ago. And so here, let's watch the landing. This will be from two angles, from east and west, and you'll see that it is a very interesting and very unusual place. One major difference here between this object and Earth though, is that there's just not enough sunlight. As a matter of fact, you get roughly around 1/100th of sunlight even during daylight. So this would be a very, very dark place. It would not really be a good place for us to bring any kind of solar panels. Anyway, so here we go, the second part of the landing, where you get to see what it looks like from the other side. Now it might look a little bit unrealistic, but this is because the camera used here were meant for dark exposure as well, so it's not really accurate in terms of color. But anyway, so there is that bounce and the slide. You get to see the little rocks that are literally made out of water, but this is much harder than typical ice. And you're about to also see the parachute shadow right there. If you'd like to see the whole thing though, I did make a video about this a few years ago, so you can check it out somewhere above my head. So it obviously was quite a huge surprise for a lot of space enthusiasts and for myself as well, that NASA announced their 4th New Frontiers mission. This mission is going to be this beautiful drone-like helicopter device that's going to be sent to Titan to explore the surface, to look for life, and to try to discover the mysteries of this object completely by itself, autonomously, in approximately 7 years from when I'm making this video. Although the actual landing is not going to happen until 2034, because it does take a while to get to Saturn. And as I said, this is the 4th mission of the New Frontiers NASA program, the other 3 being New Horizons, that was responsible for taking photos of Pluto and for recently visiting the object known as Ultima Thule. The Juno mission that's currently exploring Jupiter and its moons and is taking some incredible photos around Jupiter, and is also the record holder for the farthest mission to use solar panels. As you can see, there are 3 very large solar panels here, making this a very interesting mission. And lastly, the OSIRIS-REx mission that's currently trying to analyze the asteroid known as Bennu, and is eventually going to retrieve a sample of this asteroid and return it back to Earth. And so this one here is the 4th and probably the most advanced and most complex mission NASA has yet to plan. Here we have a very interesting kind of a drone-like device. Technically it's a helicopter or octocopter because it has 8 different blades. Each blade is going to be roughly around 3 feet or about 1 meter large. And overall, this device is going to be size of a small car, roughly around 450 kilograms in mass or approximately 1,000 pounds. It is definitely going to be one of the most complex landings and one of the most complex autonomous drones out there that has ever been created. Now, the interesting thing to notice here is that it is actually going to be technically a quadricopter, but it has 2 blades here for, well, really for emergencies. In case one of them fails, it can still easily fly with just one of these blades being active. And the way that it's designed and the way that the atmosphere of Titan is in general, it's going to be able to fly here very easily without any challenges. Due to very low surface gravity, along with really high pressure, technically it's going to be about 40 times as efficient at flying as it would be on Earth. So in that sense, it's not really something that's impossible. As a matter of fact, this is not even the first proposed flying mission to Titan. Back in the days, 2 other flying missions were proposed and unfortunately rejected. One of them was based on a kind of a balloon that would just float around the atmosphere of Titan and would use a sensor right here to explore the surface. The other one was an actual miniature airplane with a kind of a propeller in the back that would do pretty much the same, and unfortunately both of these missions were eventually rejected, but not this one. And this mission is now officially known as the Dragonfly and is definitely going to be funded and launched in 2026. Now, what exactly is Dragonfly going to study on Titan? And, well, not a lot, but there are 4 major components here. One of them is going to be a device that's going to study weather effects and also earthquakes, or technically Titan quakes. The other device is going to study atmospheric composition. There's going to be a device that's going to study chemical composition from samples. And lastly, there are going to be really complex cameras to take photos and to try to provide an overall view of what we're looking at. But also there's going to be an antenna, of course, and that antenna is going to be used to communicate with Earth. However, because Titan is so far away, it's going to take approximately 43 minutes for signal to get back to us. So we can't just control this rover with a remote control. It has to be completely autonomous. And that's where the challenge begins, because this beautiful device is going to have to do everything by itself. It has to land, it has to choose the correct area, it has to analyze any dangers or hazards, and it has to be able to decide for itself if it's safe or not to fly. It can only fly during daylight because it's not going to see anything at night, and the day here lasts for 8 days. The night also lasts for 8 days, so it has to just stay on the ground. And because there's nothing on Earth that can resemble Titan, other than, I guess, Antarctica in some sense, it has to be able to train itself using really complex machine learning algorithms and try to improve itself as it goes, because otherwise it's going to be a failure completely. All of the energy is going to be coming from here, and this is known as the RTG, which is a type of battery that uses the decay of plutonium that you see on the screen right here as the source of power. A lot of previous missions use this as well, including, of course, the Curiosity mission that's on Mars right now. RTG is going to be responsible for recharging the batteries overnight for those 8 days. And then during the day, the Dragonfly is going to be exploring the surface and can actually stay in the air up to 4 hours on a single charge. And at the same time, it can fly up to about 12 kilometers or 8 miles in a single go. So it's going to be able to explore the area nearby where it lands in a location known as the Shangri-La Dunes. It's this darker patch on the surface of Titan, very close to where the original Huygens landed as well. And one of the reasons this location was chosen is because, first of all, it's kind of flat, but second of all, it's very close to one of the well-known craters here that we believe has a high chance of having liquid water there, but also possibly some signs of life. Now, Titan is a very mysterious place for many reasons, but one of them is that there are these unusual cycles of methane that could not be explained. And as you know, here on Earth, methane is produced by life usually. So for a very long time now, scientists have been speculating that the beautiful object known as Titan may actually have very unusual life that has evolved to live on this very cold but very beautiful moon. And because it's literally covered in very similar conditions to Earth other than the temperature, it would not really surprise anyone if we found life here pretty quickly. And so despite Titan being so cold and somewhat dark and unfriendly, it's still one of the best places for us to potentially discover extraterrestrial life. And this is exactly what this mission is for, and that is why it is probably one of the most exciting future missions coming out of NASA. Anyway, so that's kind of all we know about the Dragonfly so far. It's still in very early development, but it's definitely going to be happening within the next 7 years or so. And as we develop this a little bit more and as we learn more about the mission, I'm going to do a follow-up and explain a little bit more about why it's important, but also what we might end up finding there on Titan. Now, I don't know if YouTube is still going to be a thing when this mission finally lands on Titan, but if it is, I'm definitely going to be making a video about it, although I'll probably be a lot older. I think I'll be in my 50s by then. And yeah, so expect the future Anton to explain to you what's going to happen here. Hello wonderful person, this is Anton, and in this video we're going to be talking about my favorite object, Titan. This is the moon of Saturn that I personally always refer to as the most Earth-like object outside of Earth. And we'll talk about a new discovery coming from here when trying to identify some of the lakes on the surface of this moon. So when it comes to choosing the most favorite object in the solar system, for me it's always about Saturn, and specifically about one of the moons of Saturn known as Titan. The moon itself is relatively far from Saturn, you can actually see it, it's this tiny object right there in the middle, and Saturn itself is here. And what makes it so unusual and so interesting, of course, is that it possesses a lot of things that our planet Earth possesses. There are things like the liquid cycle here, there is a lot of interaction between the atmosphere and the liquids on the surface, and at the same time it has very thick atmosphere, even thicker than planet Earth. But before we go and try to settle this object, you also have to remember that it's really cold here, and the liquids here are not water. There are things like methane and ethane. And if we were to peer beneath this atmosphere, we would discover quite a lot of various lakes and a lot of, I guess, sea-like objects. But more recently, as some of these scientists were looking at these lakes, they realized that some of them didn't really make sense. A lot of these lakes had very unusual structure that would indicate very peculiar origin. And more specifically, what some of the lakes here indicate is that the actual rim where the water ends and the surface begins are way too vertical and way too steep. It's a little bit easier to see if we zoom in here, and you'll notice how these rims are way too vertical. Now, by the way, this is actually not an actual image, this is an artist interpretation of what's happening here, but the images that we do have are very precise and very thorough, because the Cassini mission that was in this region for a very long time was able to take quite a lot of radar data over many years that it spent here. And on top of this, Titan is the first outer solar system object that we were able to film with Huygens probe that landed on the surface many years ago. So this is what the actual imagery looks like. This is not a simulation, this is not CGI as many people claim. These are the real images that you're looking at and what the surface of this moon looks like. Now the color here is false, it's not actually that orange, mostly because it's really dark here, so they had to use very specific cameras to film this. And the darkness here is actually caused by the super low amount of light that this object receives. So first of all, because Saturn is so far away, it only receives about 1/100th of sunlight that we get here on Earth. But at the same time, due to the very thick atmosphere of Titan, that amount of light decreases dramatically. So if you were to stand on the surface of Titan in the middle of the day, you would only get a very small fraction of total sunlight we get here on Earth. it would most likely be even darker than what you get from the moon in the middle of the night here on Earth. But anyway, here we go. Here's an actual landing and what the actual surface looks like as well. Some of the first ice rocks that we were able to see, and lastly you're going to see the shadow of the parachute as it lands. So once we were able to film this, and once we took all of the other radar imagery from Titan, we were able to create a map of the surface here and start even mapping specific ridges of various lakes. And it just so happens that some of the lakes in the North Pole here, and really this lake right here known as Winnipeg Lacus, or is it Lacus? Anyway, it just means Lake Winnipeg, which actually is the same name we have for a lake here on Earth. So this lake here does seem to have these unusually steep rims, and it's very difficult to explain how this was formed. However, we do have something similar here on Earth. These are known as karst lakes or karstic lakes, and as you can see, they do also have these vertical rims. And we know that these form when water dissolves the rock itself. It actually dissolves the limestone, and as it dissolves the limestone, it slowly gets lower and lower underground and forms these vertical rims. So in some sense, it's possible that maybe the methane and ethane, liquid methane, on the surface of Titan dissolved some of this ice rock that was formed by water ice and created similar vertical rims. But there is, however, another explanation that a lot of scientists are now investigating. Because unfortunately, unlike these lakes here on Earth, the ones we've detected on Titan have much steeper and more pronounced rims that we can't really explain with a simple idea of methane dissolving the ice underneath. Something else must have happened. And specifically for some of the smaller lakes like this one, this is the same lake I showed you before, it's a lot more likely that something must have come from within. In other words, there must have been some kind of a large explosion, almost like a volcanic eruption, that created these very steep rims we're observing. By investigating the shapes and morphology of these rims around this lake, the scientists behind this paper proposed that it must have been some kind of a really large volcanic explosion that created these much smaller lakes. Their size is roughly around 10 to maybe 20 kilometers in diameter, so there is a possibility that they were created by a very large explosion, and they believe the explosion is also the best explanation for why these rims are so much taller than what we expected them to be. And at the same time, it gives us an idea that maybe Titan is also a very actively volcanic object. Just like Io, it might possess several volcanoes that once in a while erupt and create these really unusual lakes, but also maybe other conditions. But what could have possibly exploded and what could have been released into the atmosphere of Titan? Well, today we know that Titan's atmosphere is very enriched in nitrogen, just like the one here on Earth, but here there's even more nitrogen. And when it gets colder on Titan, this nitrogen can become rain and then fall onto the surface and sip through the water ice and eventually get deposited underneath inside of the ice crust. And this can maybe form nitrogen lakes or nitrogen-like liquid formations underneath the surface. However, once in a while, especially I guess when Saturn comes closer to the Sun or when Titan starts experiencing its own version of the summer, some of the methane, which is of course a very powerful greenhouse gas, can suddenly create a lot of warmth on the Moon, and this may in turn initiate a kind of an explosive reaction where the nitrogen that was inside of the Titan's surface, or underneath the surface that is, suddenly explodes and releases a tremendous amount of nitrogen into the atmosphere, which then restarts the cycle again. Now, we believe that this is a pretty good explanation for what we're seeing here. We know that there's a lot of nitrogen, we know that there's a lot of circulation of various atmospheric gases, and we also know that these particular lakes seem to have been formed somewhat violently, or at least it appears so. And if all of this is correct, it means that Titan is definitely a lot closer to Earth than we imagined. At the same time, this gives us an opportunity to study Saturn in more detail and discover what happens when these eruptions do occur, or if they somehow give Saturn another ring, because it probably releases a lot of material into the outer regions of the Saturn system as well. And some of this material might of course create another ring. Now, we might be able to discover the signs of these previous eruptions if we look around the orbit of Titan, and we might even find particles in this region. We haven't looked yet, but there is a mission coming up in a few years known as Dragonfly that's going to be launching in 2026, and will be delivering this beautiful helicopter to study Titan in a lot more detail. And this is maybe when we finally discover something interesting here and possibly even life? Because a lot of scientists do think that maybe there is some kind of a life happening here after all. But anyway, even though we normally don't talk about Titan too much, I definitely think it's one of the more exciting objects out there and creates an opportunity for us to one day create an amazing colony somewhere else that will be quite self-sustainable as well, because there is a lot of potential resources on this moon. Hello wonderful person, this is Anton, and this video is completely unplanned. As I was using Universe Sandbox, I just discovered they had a new update where they introduced a new simulation known as the History of Saturn's Moons. Now, I generally use this tool quite a lot to explain various things in space and of course space sciences, and because of this I wanted to showcase what they've actually added, talk a little bit more about it, and also explore this with you as I actually haven't really tried it yet. At the same time, this is a bit of a promotion for Universe Sandbox because it's such an amazing tool to learn space sciences. Well, anyway, it starts right here, and here is their simulation of Saturn. As you probably know, Jupiter was always the kind of a leader in terms of the amount of moons that we've discovered, and as of 2019 we've discovered 79 different moons around Jupiter, so it's no surprise that because of its more massive size and because of its actual mass, we assume that Jupiter is probably going to stay as the leader forever. But it turns out that in 2019 we discovered, completely by accident, 20 new moons of Saturn, giving it a total record now 82 moons. Now, because of this discovery, we also started thinking about, well, maybe it's time for us to reclassify moons as well. Maybe moons that we kind of think of as moons, and also the moons that we just recently discovered, are not really the same object. Maybe we should classify them as something else. In one of the previous videos I proposed that we name them dwarf moons, just like we did with dwarf planets, but it's probably going to take a while before we come up with a good term. But anyway, so here is the second image that we get to see in Universe Sandbox, and it briefly tells us about the first discovery of Titan. Titan, as you may already know, is the moon of Saturn, but it's also one of the most interesting moons, if not the most interesting moons, in the solar system. Discovered in 1655 by the Dutch astronomer Christian Huygens, this beautiful moon contains very thick atmosphere, as a matter of fact with more atmospheric pressure than here on Earth. We've also detected a lot of really unusual activity here. We've detected things that might resemble actual life activity, suggesting that maybe there is some kind of a weird life going on here after all. It hasn't really been confirmed yet, but we've, for example, seen unusual patterns of methane that has not been explained just yet. And as you know, here on Earth, methane is usually associated with life. Here's, by the way, what Huygens may have looked like, and as you also know, the probe that landed on Titan and took amazing, beautiful images and actually were later compiled into this beautiful video that you see, were named after him as well, so the Huygens probe is named after him. Then, a few decades later, between 1671 and 1684, we have a few more discoveries, this time from an Italian astronomer working under the financial support from King Louis XIV of France. Now, back then, this is kind of how it worked. If you were a famous astronomer, or if you were any kind of a famous scientist, you would usually get some kind of a patronage, or basically financial support, from a kingdom or an empire, and this is how you would literally live your life. But what did the King Louis XIV get out of having this guy, Giovanni Cassini, working for him? Well, prestige, bragging rights, and the fact that Cassini was responsible for directing, building, and establishing the Paris Observatory that then became pretty famous afterwards. So this is kind of how things worked back then. Oh, and Cassini, by the way, discovered 4 more moons of Saturn. You can kind of see them right here. There's Tethys, Dione, Rhea, and the 4th one is right here. This is Iapetus. So he was able to discover them, and he was obviously the first to do so. And because this was his biggest discovery and he was essentially the first to find these moons, the Cassini mission was obviously named after him, among a lot of other things around Saturn. And then 100 years or so passed, and in 1789 it was William Herschel who discovered 2 more moons. We have the moon Mimas, and the famous Enceladus, where we currently believe there might be life, or actually inside of which there might be life, because what we've seen on Enceladus is absolutely incredible. These beautiful geysers that emanate from the surface are very likely caused by an extremely active and also very energetic liquid ocean on the inside that's very likely driven by all sorts of volcanic activity that's coming from the inside. And all of this results in these beautiful emissions that are responsible for creating one of the rings of Saturn. It's known as the E-ring. Here's actually one of the images that was taken by the Cassini, and as it passed through these particles, it even got to kind of detect what's on the inside, and we've discovered a lot of really cool things. No life yet, but a lot of organic materials that could produce life. And the current models suggest that Enceladus may look something like this on the inside. This was made by NASA when all of this was discovered. So we think that there's a pretty thick layer of ice, then there is the liquid ocean, and then there is some kind of a rocky, very likely terrestrial core that's relatively small in size, but nevertheless is there and is responsible for all of this activity. And for all we know, on the actual surface of that rocky insides is maybe where we can find some unusual Enceladian life. Enceladian, that's a pretty cool word. Can't wait for us to actually discover this. But the thing is, these moons were not named this until middle of 19th century, 1847. Specifically, it was actually Herschel's son, John Herschel, who proposed naming all of these moons not after kings or queens or any royalties, but after Greek mythological characters. Specifically, after the Greek Titans. So all of these were actually Titans in Greek mythology. And very shortly after, in the middle of 19th century, that's when a lot of astronomy started to kick in and people started to compete. So the 8th moon, Hyperion, was actually discovered by two separate teams. One of them was William Bond and his son George, but it was actually William Lassell who later published the paper about the discovery of Hyperion and was technically credited as the discoverer of this moon. This friendly competition, of course, created a lot of opportunities for astronomers to now start discovering and naming new things, and the middle of 19th century is when we started to get a lot of new data coming from various objects in the solar system. Then in 1899 we discovered an unusual moon known as Phoebe. But this moon was not discovered by looking at it directly through the telescope, it was actually discovered in a photographic plate that was taken a year before that. And interestingly, this moon is what's known as the irregular moon of Saturn. This moon moves in the opposite direction. It also may have come as a kind of a captured object, so it was probably an asteroid before, and very likely it did not form as other moons that were there from the beginning of Saturn's life. Here in this simulation you can even see that Phoebe moves clockwise, while every other moon of Saturn actually moves in the opposite direction. They all move counterclockwise. And this is typical of these irregular moons. The new moons discovered around Jupiter and the new moons discovered around Saturn, they're all irregular moons that have very similar unusual patterns, suggesting that all of them were a result of a capture later on in the existence of both planets. And then we come into the 20th century. This is where all of the other discoveries happened. And the first discovery was in 1966, and this was an astronomer known as Adwin Dolphus. I had to read this, his name is pretty complicated. He discovered this moon right here, this is known as Janus, and only a few days later, another astronomer, Richard Walker, also seems to have seen it in a very similar orbit. But there was an unusual anomaly in their observation because the orbits seem to have been a little bit different. And it took a while, it actually took a few years, specifically 12 years, for us to realize that they were looking at two different moons that had the same orbit but were actually in the Lagrange point of each other. So Janus is right here, but the second moon, Epimetheus, is on the opposite side. So they basically are in a relatively similar orbit, but they are on the opposite side of Saturn and never get to see each other. And then in 1980 we started discovering more unusual moons. Here we have Helene, Telesto and Calypso, all three of which are what's known as Trojan moons. They are also in the Lagrange points. By the way, here's a quick reminder of what Lagrange points are. In every orbit around a more massive object, the smaller object will have these really stable permanent orbital points where you can have things staying in there and not really falling into either object. These points are known as Lagrange points. The most famous one is probably L1 and L2. This is where we place a lot of satellites to observe either the Sun or Earth. We also obviously have L3, which is the opposite side, but then we have these 2 points, L4 and L5. And usually if you find any kind of an object, like for example an asteroid or a smaller planetoid orbiting there, we normally refer to them as Trojans. Jupiter, for example, is so massive that it's believed to have thousands, if not millions, of different Trojans, many of which have already been discovered and many of which are just too small for us to see. And so obviously it shouldn't really come as a surprise that Saturn also has these Trojans, but I guess what is surprising is that they're Trojans of the moons of Saturn. Specifically here, you can kind of see that this moon right here, Telesto and Calypso, are the Trojans of the larger moon Tethys. And Helena here is the Trojan of the moon Dione. So they're all located in a kind of a 60-degree angle known as the Lagrange point. Specifically here, because these moons are in these positions, they're going to be in a really stable orbit around Saturn for a pretty long time. Then the arrival of Voyager 1 and Voyager 2 probes discovered a few more moons, and here all of them were actually inside the rings of Saturn. We have Pandora, Atlas, and Prometheus. While at the same time, the Voyager probes also confirmed the discoveries of all of the previous moons as well. Then, interestingly, about 10 years later, we've also discovered, completely by accident by the way, the moon known as Pan. This was such a small moon that it was really difficult to see it, but we saw it in one of the pictures taken by the Voyager 2 probe. Here is what it sort of looks like. You can see that it's barely even visible between the rings of Saturn. And it also became really popular because it turns out that it's shaped like a ravioli. A few moons of Saturn do have this unusual shape, and later on we realized that all of this is a result of a really complex interaction between the moon itself and the rings of Saturn as they deposit around the moon and create these really unusual, really interesting shapes. Here are the pictures taken by the Cassini, and you can see that the moon looks really unusual, but it also suggests that many smaller moons, specifically moons orbiting around rings, may start this way and eventually become bigger and bigger, turn spherical, and might end up looking more like the moons we know today. So this could be what an embryo or a baby moon looks like. And then in the beginning of the new century, in 2001, we discovered a lot of other irregular moons. You can kind of see all of them here. And all of this came as no surprise because we've always believed they existed there, we just didn't really know how to look for them and also how many there are. And it's very likely we haven't even found a fraction of them yet. It's very possible that there are thousands and maybe millions and who knows, maybe even more tiny moons out there. Here are some more moons discovered in 2005. All of these were also irregular moons of Saturn, but the most important discoveries were actually done between 2004 and 2009 when the Cassini mission discovered some of the inner moons as well. The most interesting discovery was actually this right here. It doesn't really have a name just yet, but the interesting thing about it is how it was discovered. It was by looking at the images of Saturn's rings and seeing this unusual shadow that the moon formed by passing essentially above the ring is how we were able to actually see it. It's so tiny that it would be impossible to see it in any other way. The moon itself is only about 1,000 feet or 300 meters in diameter, but the shadow that it created was about 36 kilometers large. So that's basically how we were able to see it, even though at this point it's, I guess, a little bit difficult to see, is this really a moon or is this just a chunk of matter inside the ring? And at the same time, this is where we kind of need to start thinking about, so what exactly is a moon and what exactly would be just a particle in the Saturn's ring? How do we start differentiating one from another? Then, in 2006, a famous astronomer, Scott Shepherd, announced the discovery of several more moons, specifically 9 more moons, but this was done with a ground telescope, the Subaru telescope. And this is what this beautiful Subaru telescope looks like. This is in Hawaii, on top of a mountain, just under 14,000 feet in the air, or about 4 kilometers up. Basically, it's on top of a very high mountain, and because of its very large mirror and also because of the design and the location, it's able to very easily see the night skies, and this is how it was able to discover those moons we haven't seen before. At the same time, this is also the primary telescope right now that we're using to try to discover Planet 9, if it exists. We're hoping to find it within the next 5 years, but even if it doesn't exist, we'll probably still see a lot of other things we didn't really expect to find. Then in 2007 we saw 3 more moons, but here unfortunately for 2 of them we didn't really calculate their orbits too accurately because it was very difficult to see them, and so they were considered to be lost. And so 2 of them, this one here and also that one right there, were technically lost until very recently. And it was only in 2019 that we finally rediscovered where this moon was. However, this right here is still technically considered to be the lost moon of Saturn because we're not sure what its actual orbit is. And lastly, in 2019, this is when Scott Shepherd again discovered 20 more moons, irregular moons of Saturn, using the same Subaru telescope. But unfortunately 5 of these moons are considered to be the so-called lost moons because their orbits are not precisely known. You may want to check out the video I made previously where I do talk a little bit more about the discovery and also the competition that NASA is running to try to name these moons. But in a nutshell, this is what the 82 moons of Saturn are, and this is how we discovered them, and then this is how essentially the astronomy progressed since the early 1600s. Now honestly, it's a pretty exciting time to live in because the technology has reached the point where we can easily see these objects in the night skies using very complicated techniques, and using a lot of really complex analysis, we can even predict where certain moons could be, and then possibly find them there. This is essentially how we're looking for Planet 9, of course, by using a combination of observation and prediction. Now we don't really know what else we'll discover around Saturn in the next few years, but it's probably going to be even more moons, and very likely moons that were previously lost will be rediscovered and their orbits will be more specifically determined. For now, the exciting part about all of this is, of course, trying to find a way for us to get back to the inner Saturn system and to hopefully launch a successful mission to first Titan, but also Enceladus. Now the mission to Titan is already being planned. That NASA mission is currently known as the Dragonfly, but we still are yet to decide if we're going back to Enceladus and if we're going to try to reach the ocean of Enceladus, and if so, how. Nevertheless, very exciting times to live in. Hopefully in the next decade or so we'll get a lot more discoveries coming in from this beautiful system, and hopefully we'll get to make some incredible discoveries right here on Titan as well. And this is definitely one object I would love to learn more about. Hello wonderful person, this is Anton, and in this video we're going to be talking about beautiful Titan. And more specifically about this beautiful map that you see on the screen that was recently created by scientists, allowing us to create the most detailed map of Titan to date. So by now you might be already aware that Titan is the only other body in the solar system where we have officially confirmed actual liquid. And more specifically, lakes. This object here has actual lakes. And although Titan is not actually a planet but a moon of Saturn, nevertheless it possesses a lot of properties that could technically make it a planet, or at least a new type of an object. This is sort of what it looks like compared to Saturn, and if you were to look into the atmosphere of Titan, which we have done using the Cassini mission and also the Huygens probe that landed on Titan, you would discover something that looks like this. This hazy and very thick atmosphere that's even thicker than the one here on Earth. Scientists have even speculated that if you were to go to Titan and essentially bring a couple of really small wings that you could attach to your own arms, you could fly there, simply because the atmosphere is really thick and the gravity is really low. And this is also one of the most well-studied objects in the solar system, simply because it's the farthest object we've landed on. Here's a simulation of what the actual collision or landing was like, and we do have an actual video that I've discussed previously that shows us what the surface sort of looks like. And interestingly here, these rocks that you see everywhere, they're not really rocks. They're basically just ice chunks, or big chunks of water that was frozen for millions and billions of years. And so it's no surprise that Titan is a very exciting place. There are a lot of things here that do resemble planet Earth in a lot of ways, even though it's a lot smaller than Earth. And the fact that it has atmosphere and it has actual liquids on the surface, although not water, it's actually things like ethane and methane, all of this together makes this a very exciting world where we're hoping to find the first ever extraterrestrial life. Which is why the release of this paper that came out in Nature magazine made me really excited, because Titan is basically this one place that I would really love to visit one day. The scientists behind this paper essentially were able to combine all of the data that was collected over the years by the Cassini mission, and all of this was then combined into this first ever relatively comprehensive map of Titan, with actual features examined in a little bit more detail. Now, we did have maps of Titan before, and as a matter of fact, even Google Maps has this image that you see right here that's represented through the collection of all the data we've received from Cassini, but it's not really that clear what we're looking at here. We even have a somewhat similar map right here in Universe Sandbox that you can examine, and some of the features are visible here, but the thing is, it's still quite impossible to tell what's what. What exactly is a lake, what exactly is a mountain range, and what exactly is a simple plain. So this paper does just that. The entire focus of this is to try to summarize where things are and where, I guess, important things are. And interestingly, even though it doesn't really look that detailed, it does provide quite a lot of interesting information, along with certain words that I've never really heard of before. But this, by the way, just means mountains and hills. So first of all, this right here are the lakes. The lakes are in the north, but they only cover about 1.5% of the entire surface. And that's really insignificant when you compare it to Earth, where the percentage is closer to about 71. So here, there is practically no liquid. But all of the liquid that is here is in the north. Now, you might be wondering why, or you might have already guessed why. It definitely has something to do with the seasons, because the northern part experiences a lot more summers, or technically longer summers, because of the orbit of Saturn around the Sun. So due to the elliptical nature of Saturn, the northern part here is, I guess, in some sense slightly warmer than the southern part. And this is a very unusual feature that doesn't seem to exist anywhere else in the solar system. Although there is at least one major lake in the south known as Ontario Lacus, named after the province of Ontario, and the origin of which I've discussed in one of the previous videos. So in that sense, the amount of liquid here is definitely very unusual. At the same time, right here in the so-called equatorial area of Titan, there is a lot of really unusual dune-like formation, which doesn't seem to exist on the polar regions. And this is probably due to the rotation of the planet and the way that all of the stuff gets deposited on the surface. There are also these occasional areas known as labyrinth, and you can find more of them by going to Google Maps and actually seeing the specific labyrinths that are located on every individual one of them and seeing what they're called and what exactly they're named after. But these labyrinths are basically just valleys that were formed by rain that essentially carved the ice rock and created these unusual formations. Now on our planet, valleys are usually formed through the interaction with water. Usually rivers carve them, or a lot of rain activity as well. And so similar effects are probably causing the valleys on Titan, which suggests that liquid methane and ethane flows occasionally and forms these unusual regions that would be absolutely beautiful to look at one day. But unfortunately, all of the images we have of these features are not really that detailed, so unless we go back there and land an actual probe or a rover, which we are currently planning by the way, we're not unfortunately going to be able to imagine what exactly all of this looks like. Now, about 14% of the entire surface is hummocky, or basically has hills and mountains, which is quite expected from any object really. And about 17% are these dunes, which form very likely due to the wind activity on the surface of Titan. And because the Titanian atmosphere is a lot thicker than the one on Earth, it very likely creates a lot more wind activity as well, although possibly not in terms of the actual speed, but definitely in terms of strength. And so here I would expect dunes to be pretty much everywhere, which they seem to be. And because they mostly form along the equator, it's also implying that most of the wind activity is along the equator, not so much in the pole regions. And the rest of Titan is basically just plains, which is great news for us because plains are usually the regions where we would like to land different probes. So in terms of landing opportunities, there are quite a lot here. So it's going to be very exciting when we finally launch the next probe to go to Titan. The next probe is actually going to be this is the Dragonfly mission, and its launch date is currently set for 2026. But You never know, maybe China decides to make it here first and maybe they'll be the first to land on Titan. But unlike previous probes, Dragonfly is going to be a helicopter. And it can totally work here because of the thickness of atmosphere and because of the low gravity of the object. Although since using solar panels here will be completely useless, the Dragonfly is also going to be equipped with its own RTG, or essentially a nuclear reactor. So in a decade or so, it's definitely going to be a really exciting mission to follow. Now, apart from that, there was also another really major discovery, and the discovery is that there are not that many craters. And we technically expect the craters to be everywhere because pretty much most of the objects in the solar system have experienced a lot of different collisions. So the absence of craters suggests only one thing, that the surface of Titan is exceptionally active. There are a lot of things going on here, and it's very likely that the surface gets renewed very regularly, suggesting that the craters simply disappear with time. But the biggest discovery in this paper is the diversity. The amount of different features and the amount of activity that's present on this object. Except for Earth, there is no other object in the solar system that has so much stuff going on, that has an actual active liquid cycle and atmospheric conditions that do mimic to some extent planet Earth. There is no other object in the solar system that presents more opportunities for us to discover actual extraterrestrial life, and if we ever discover something here, it's very likely not going to be that surprising. We've already witnessed quite a lot of signs suggesting that something unusual is going on here, especially when it comes to atmospheric circulation. For example, unexplained methane clouds that are still not entirely well understood. Hello wonderful person, this is Anton and welcome to Saturn. Today we're going to be talking about the recent announcement that we've just discovered 20 more miniature moons around this beautiful planet, making this now the official record holder for the most moons in the solar system. So it was actually only a matter of time before we found more moons around these large, extremely exceptionally gigantic planets known as gas giants. We've actually known about various hidden moons for a very long time, and we've even discovered a few more around Jupiter back in 2017. There was a video I made back then explaining exactly what these moons were and how they were created, and why we were more likely to find a lot more relatively soon. Well, it took only 2 years, but this time it was not around Jupiter. It was around its neighbor Saturn. And although there are still, I guess, 79 known moons around Jupiter, Saturn now has 82. And what's really interesting here is that it was such a huge amount of new moons discovered by a single study. They were literally able to very accurately identify and analyze 20 specific objects around the orbit of Saturn, each of these roughly around 5 kilometers or so in size. Although some of them could actually be a little bit larger than 5 kilometers because we're not entirely certain of their current size. And as you can see from this image here, the moons are now officially divided into 3 family groups, based on their orbits around Saturn. So the closest moons that orbit in the same direction as other moons, the so-called prograde orbit, are known as the Inuit group. And the Inuit group is basically named so that we can give these moons names of Inuit gods, basically gods of Inuit mythology. And the Inuit people that you see right here have one of the richest mythologies ever. There's a lot of gods there, so there's definitely going to be a lot of really cool names we can pick. Then the second group, the Norse group, that's the largest group discovered, and all of these will be named after various Norse gods. So probably not Thor and not Freya, but some other less known gods because all of the other names have already been taken. And lastly, the smallest group is the Gaelic group, and that's the one that will be named after the Gaelic gods. Now, why do we have these 3 groups of various mythologies? Well, that's because pretty much as soon as these moons were announced, and essentially as soon as they were discovered, the Carnegie University asked for help naming them. And I'm posting the link for this contest in the description below, but basically here you have until December 6th of 2019 to propose various names based on these mythologies, and your name might get picked. Now, if you don't know anything about those mythologies, well, that's probably a good chance for you to kind of catch up on your reading and to discover either Inuit, Norse, or Gaelic mythological creature or entity or god that you would like to propose for a name for these various moons. But there are actually quite a lot of really interesting discoveries coming from this study. For one, as I mentioned, the orbit of the closest of these moons takes about 2 years. Just to give you a comparison to my favorite moon of Saturn, which is this right here, Titan. This is already pretty far away from Saturn. You can kind of see Saturn right there in the back. And a single year here, or a single orbit around Saturn, takes about 16 days. But these farther moons have a much farther distance. An orbit here takes 2 years. And just to help you visualize how far away this is, let's recreate this very briefly in Universe Inbox. So here, just for fun, I decided to name one of these moons, and it's actually from Inuit mythology, and the name is, oh my god, I'm gonna totally butcher this. Ildrivirisisong. Ildrivirisisong. That's pretty good. I think that's pretty spot on. By the way, Sedna, that's another one of the dwarf planets we have on the outskirts, is also named after Inuit gods. But anyway, so Ildrivirisisong, according to Inuit mythology, is the demon cousin of the moon. Sometimes it comes out into the night skies to dance and make people laugh. But if anyone is nearby, the people must restrain themselves, or the demon clown will dry them and eat their intestines. Right, so looks like I picked a good name. But anyway, so this really complex name is just an example of one of the names we could potentially pick for the naming of these various moons. And here, if you look at the orbit, it is really far away from Saturn itself. So there is Saturn, there is Titan, you can kind of see it in the distance, and the moon I just placed is on the outskirts, somewhere right here, and the distance here is about 1/10 of a distance of Earth to the Sun. So this is actually pretty far away. In reality, I think it's a little bit less than that, but this is kind of where some of these moons are located. So they are really far away from Saturn itself. But for the most part, they probably all look very similar to what you see on the screen here. Today, we believe, based on the discovery, is that there are actually 3 much larger bodies that were probably responsible for creating these moons. Essentially, what happened here was probably a very large collision between a proto-moon, or basically a much larger asteroid, that got captured by Saturn. Just based on what we're seeing here, the scientists were able to figure out how all of this very likely happened. They were probably all made from a rock slightly larger than the one you just saw. This is probably, I don't know, about 6 or so kilometers in radius, possibly a little bit more. And this was probably an asteroid or a very early protoplanet that never really got to become a planet. And this particular rock was very likely traveling through the early solar system, the so-called protoplanetary disk where all of the planets were made, and somewhere out there, somewhere in one of these gaps, was Saturn. And as it traveled through this gap, it basically got attracted to Saturn, to its gravity, but at the same time the dust in between these rings started to slow down this asteroid, and at some point it essentially got captured by Saturn itself. So in other words, it kind of looked something like this. Normally, a rock or an asteroid passing next to Saturn would most likely just experience basically a slingshot maneuver. It would do something like this. It would have its orbit bent a little bit, but would not really get captured by Saturn. For this to happen, something needs to slow it down. In other words, for this asteroid to become a moon of Saturn, as it passes close to Saturn, or as it passes really at any distance away from Saturn, it needs to have its velocity decreased. This is literally how we were able to get into orbit of Saturn with the Cassini mission, and this is pretty much how all of these moons were able to acquire these orbits as well. But how can it slow down? Well, one way of slowing down is if it starts hitting some kind of a dust field. In other words, if it flies through the protoplanetary disk of the early solar system, kind of like what you see here. So if this rock now moves through the orbit of Saturn and then starts hitting all of this dust that is still there in orbit around Saturn and also basically everywhere in the solar system, all of this dust will eventually slow this rock down to the point where it gets captured by Saturn. And this is kind of how we think all of these irregular moons of Saturn and Jupiter came to be. In other words, even though there are many moons that were created during the formation of Saturn and were even made from the same material as Saturn itself, such as for example Titan, we think Titan may have been made along with Saturn, there are still a lot of other moons that were definitely captured afterwards, specifically right after the creation of Saturn, but before the protoplanetary dust dissipated and before the solar system became the same way as it is today. And based on what we're seeing here, we think that this happened at least 3 times. So there were at least 3 separate captures, and very likely a lot more that we haven't discovered yet. And then when these larger pieces got sort of captured by Saturn and started orbiting around it, eventually they received a collision from something. Or maybe they just fell apart for some other reason. But this is literally how we believe all of these parts were formed. This is why we believe they all have very similar orbits, but at the same time they're not in a single piece. They must have collided with something else and got destroyed into tiny pieces, which suggests that it's not just maybe 20 or so moons here. It's probably thousands if not millions. It's just most of them are very, very small to detect. And so once we're able to use a more powerful telescope, something that can resolve moons up to about 1 kilometer in size, we'll very likely end up with thousands if not millions of various moons of both Saturn and Jupiter, because that's kind of what we think is here. It's not just 79 or 82 moons, it's probably a lot more. We might need to even reclassify these because we're going to run out of names pretty quickly. Remember how a few years ago Pluto lost its status from being a planet to being a dwarf planet? Well, expect that to happen with moons pretty soon. We're probably going to have a new concept known as maybe dwarf moons or tiny moons or moons. Actually, that already exists. But it's very likely that as soon as we start discovering more than we can handle, we're going to have to completely change our understanding of what's really happening here. But for now, we don't have thousands or millions, we just have 82. And all of these were discovered using the Japanese Subaru telescope that's actually in Hawaii and that's capable of detecting and resolving these very, very small objects really far away. But what's really interesting about this discovery is that it wasn't actually made recently. We had this data for a very long time. We've actually had these observations back in 2004 until 2007. But it was the use of a new algorithm that was able to discover these moons and that was able to analyze this data that allowed us to discover something that was always there. We just didn't really see it before. So the combination of new telescopes and new data analysis will definitely increase our chances of finding new objects out there in the solar system. But I guess until new moons are found or until we discover more interesting things, check out the naming contest. Maybe your choice will be picked, but also make sure that it's something that meets the criteria. It has to be one of those specific gods because that's normally how we name objects in the solar system. Hello wonderful person, this is Anton and welcome to Saturn. Today we're going to be talking about a new discovery coming from this beautiful planet related to its spin or its rotation. There are still a lot of mysteries around various planets, including of course Saturn, but the thing is, one of the biggest mysteries of this unusual planet is that it seems to have changed its rotation speed over the past 20 to 30 years or so, by just a tiny amount, but roughly around 1% or so. But how could we possibly discover all of this? Well, it actually started back in 1979 to 1980, when the Voyager probes passed by Saturn and were able to measure its rotation. These beautiful probes, one of which you can see right here on the screen, are traveling through the interstellar space right now and are still sort of sending some of the data to us. Now, one day they'll die, but not yet. Anyway, so when these probes were just beginning their scientific life, the scientists behind this mission made it so that the probes were able to use the so-called slingshot maneuver to use both Jupiter and Saturn, and for Voyager 2 even Neptune and Uranus, to accelerate a little bit and to get extra speed so that they could eventually leave the solar system. So here is the Voyager 1 spacecraft as it passes behind Jupiter and gains that extra velocity that will then take it to Saturn, and as you can see, it's now on the way to Saturn. While passing by these planets, the probes were able to get enough data to allow us to study Jupiter, Saturn, Uranus and Neptune in detail that was not available to us before this. And of course, some of that data was in regards to the rotation speed and other properties of the planets themselves. And so for Jupiter, we were able to discover that it was the fastest spinning object in the solar system, but for Saturn, we discovered that a single rotation here takes about 10 hours and 40 minutes. And this number was obviously confirmed by both Voyager 1 and Voyager 2, so there was no reason for us to doubt that this number was correct. But then we of course had another brilliant mission, Cassini, that spent a long time around Saturn, studying pretty much everything about it and its moons as well. And the Cassini mission was also able to measure quite accurately the rotation of the planet, but discovered something a little bit different. And this is where the mystery began. This was back in 2004, and we didn't really know why and what's really happening here. For both Jupiter and Saturn, they release a type of a radio wave from the upper atmosphere that we could technically see from Earth. But the Jupiter's waves do go through the atmosphere of our own planet, and thus we can see it with radio telescopes located on our planet. But for Saturn, the frequency is a little bit different, and it just so happens that that frequency is absorbed by the upper atmosphere of Earth. So none of the radio telescopes from planet Earth can be used to study Saturn, and for this reason it's always been a bit of a mystery to us. We can only use either probes that come close to Saturn, or more specifically telescopes that are orbiting planet that don't get influenced by the Earth's atmosphere. So in other words, it's always been kind of difficult for us to study the atmosphere of this beautiful planet, but nevertheless scientists managed to study it quite well, especially when the Cassini mission spent a few years here. But in order to answer the discrepancy in measurements between the Voyager probes and the Cassini probes, the scientists really started thinking outside of the box. Specifically, they had to start creating various models, including this mechanical model that was created by the scientists behind the paper that was recently released, and try to understand how is it possible that essentially Saturn seems to have changed its rotation. Now the paper that talks about this is in the description below, so you can read this by yourself if you'd like, but the idea is not actually that complicated. And to try to understand all of this, we need to take a look at the differences between Jupiter and Saturn. So here's Jupiter, and here are the moons of Jupiter. This is what their orbits look like in comparison to the orbits of everything else. Now let's take a look at Saturn. So right away you might see that the orbits of moons of Saturn are a little bit different. Specifically, here's what they look like in comparison to the plane of the solar system. As you can see, Saturn is actually sort of tilted, just like another planet that we're very familiar with. The planet I'm talking about is of course Earth, and both Saturn and Earth have a relatively similar tilt. For Earth it's about 23.5 degrees. For Saturn this angle here is about 27 degrees. In other words, both Saturn and Earth are two planets that experience seasons. Both Saturn and Earth have winter, summer, and possibly fall and spring, but winter and summer for sure. And this of course implies that both planets receive different amount of sunlight in different hemispheres. And this is where things get really interesting. So it turns out, according to the scientists behind this paper, not only does the atmosphere of Saturn sort of accelerate in rotation, but it also seems to have different speed of rotation depending on the hemisphere. So let's just call them Northern Hemisphere and Southern Hemisphere just for the sake of making it a little bit easier to understand. So the Southern Hemisphere here receives a lot less sunlight compared to the Northern counterpart. And because of this, there is a very strange interaction between the plasma that's formed in the upper atmosphere and the atmosphere itself. If we take a look at this model right here, you'll notice that the scientists were able to recreate this using essentially mechanical wheels, and they presented two hemispheres as these two different atmospheres. And then there's a ring of plasma that's created by the interaction between the ultraviolet light of our own sun and the magnetosphere and also other upper atmosphere parts of Saturn. So in other words, as this plasma forms due to the interaction with the UV light from the sun, it actually starts slowing down one of the hemispheres, and the atmosphere in that hemisphere starts spinning a little bit slower due to the drag from this plasma that interacts with some of the layers of the atmosphere. Now it might sound complicated, but essentially think of this as this right here, a kind of a magnetic break that this plasma creates. So as there is more plasma in the north starts getting slowed down by the interaction with plasma and spins a little bit slower. Not a lot, possibly about 1% slower, but still slower enough to be noticeable. And then the atmosphere that stays in the dark doesn't receive as much UV light, and for this reason obviously spins a little bit faster because the rotation is not slowed down by the plasma. So in other words, our current understanding, or technically our simulations of Saturn, are a little bit incorrect, because the upper part sometimes spins a little bit slower than the lower part. And this of course might allow us to explain certain things about various unusual patterns around Saturn's atmosphere that we still can't really explain. Now we're not really sure what all of this implies just yet because it's a very recent study, but this does explain why we were able to observe those unusual variations in data between Voyager and Cassini, and at the same time explains that other planets except for our own planet Earth seem to have seasonal changes that do affect them quite dramatically. And I'm sure that following this study we'll be able to possibly explain some of the other unusual effects that we've observed on Saturn, and maybe even explain these storms on planets like Jupiter. Now this discovery doesn't imply that the core of Saturn also spins faster or slower depending on the conditions and the seasons. It only talks about the atmosphere itself. We're currently not entirely sure if there is even a core inside, but if there is a solid core similar to a terrestrial planet inside of this object, then it's very likely that it's not really affected by any of this. So this only applies to the atmosphere. It only applies to the rotation of the gas layer on top of the planet. But what's really interesting is that now, because we're pretty much sure that this is what's happening here, it would be very interesting to see if other seasonal changes affect other objects here as well. Because we know that there is obviously objects like Titan that have very thick atmosphere, and for the longest time I've personally been calling this the most Earth-like object in the solar system, mostly because of various conditions that are present here. But this also implies that it's very likely Titan has these seasons, and they might affect the moon as well. Now, we still are not really sure what's really happening here and how all of this affects these objects, but this will definitely create a new field of study specifically related to seasons of various planets that are not Earth. Although because the single orbit of Saturn takes about 29 years, it also means that seasons here last very long. Basically, imagine having like 5 or 6 years of summer and then 5 or 6 years of winter. Well, anyway, so that's kind of all we've learned about Saturn from this new paper, and if you'd like to learn more, check out the paper in the description below. For now though, I think it's a pretty cool discovery. It definitely explains a lot of things that we didn't understand before, and we were finally able to answer, well, pretty much a 40-year-old mystery, because since the Voyager probe discovered the original rotation speed and then Cassini had a completely different result, scientists were kind of scratching their head and were thinking that maybe it was just a data problem. But this particular study definitely clarifies a lot of things, and at the same time explains that this plasma that forms in the atmosphere or above the atmosphere of these gas giants is a really powerful force.
Hello wonderful person, this is Anton, and in this video we're going to be talking about the mystery of our beautiful Saturn. Probably one of the most beautiful planets out there, or at least in our solar system. This shot was actually taken by Cassini a few years ago, and even today it kind of gives me this feeling of awe and inspiration. Today we're going to be talking about a very unusual gap in the rings of this beautiful giant that was always very mysterious and never really explained well. And we're going to find out what new discovery suggests. Something that might actually apply to exoplanets as well. So for the longest time, before I kind of started studying astronomy full time, I always believed that a lot of these gaps in the rings of Saturn are formed by various rocks, like for example miniature moons, well basically moons in general. And you can kind of see that I wasn't really off in my assumption, because a lot of them, like this one right there, Pan, seem to be orbiting in these gaps. But then there's this really large gap in the middle, known as Cassini division, that I also believed was formed by some kind of a large moon. But when I started thinking about it, I couldn't really figure out which moon it was. At first I thought it was maybe Pandora, but Pandora orbits farther away. And if you watch closer, you'll see that nothing ever really passes here. It's sort of empty. It's literally completely devoid of any object, clearing it and creating this unusual gap that's roughly around 4,500 kilometers or about 3,000 miles in size. So how exactly was the so-called Cassini division formed? Here's another look at this from the side, where you can see the Cassini division is right there, with a few more gaps here and there, but a lot of them are actually formed by various moons. And of course the very large E-ring that we now believe is formed by the eruptions from Enceladus.
and then there's Titan somewhere to the right. And so obviously I was wrong in my assumption, thinking that it's a moon, because it's not. As a matter of fact, today, because of the study specifically, we now believe that seeing large gaps like this indicates that the moon is not really in that gap. It's elsewhere. In other words, something else is causing the rings to form in such a way where the gap becomes visible, but it's an interaction with a gravitational field from another object. And to find this culprit, the scientists behind this particular paper that you can find in the description below had to look at other moons in the vicinity. Now, can you take a guess which one may have formed this? And if so, why? And to figure all of this out, the scientists behind this paper took a look at what's known as planetary or orbital resonance. That's when objects in orbit form a kind of a relationship that becomes really stable over time. In this case, a typical example of resonance would be from the neighboring Jupiter that has a very well-established resonance of its moons. And here, if you look at this from the side, you'll notice that for every 4 orbits of the closest moon, which is Io, the second moon, which is Europa, does 2 orbits. And the third moon, which is Ganymede, does 1. So the resonance here is 4-1, 2-1, and lastly, Io has 1-1. The last moon, which is Callisto, is not in resonance, which has never really been well explained, but it's probably because it's farther away. But the 3 moons here are in resonance. And so something very similar is happening here around Saturn as well. But it's actually the resonance between the moons, some of the moons, and the rings. And specifically here, if you were to look at this gap and try to figure out what is in resonance with it, you'll discover that there is one moon that fits this perfectly. And that moon is the super famous, weirdly shaped moon known as Mimas that sort of kind of resembles the Death Star from Star Wars because of this unusual formation that was created by a collision a long time ago. And interestingly, Mimas lies at a 2-1 resonance with the Cassini division. So here, if you were to look at this from top, for every 1 orbit of Mimas, the imaginary gap right there, the Cassini division gap, is orbiting twice. And that's, of course, if there's anything left to orbit. There's a few particles here and there, but for the most part, they're all gone. And the scientists behind this paper believe that the way that this was formed is by having Mimas move closer to Saturn, roughly around 10 million years ago, or actually within the last 10 million years. Now it's actually moving away from Saturn, but something made it move closer and created this gap in the same way that I guess you could call it a kind of a remote snow shovel in a sense, because technically it's shoveling away all of this icy snow that's created here through billions and trillions of particles interacting with one another. Now, all of this is done through essentially gravitational interaction, and no actual object needs to be there in the middle of the ring to remove all of these particles. All of this is done by Mimas creating this resonance. But in order for Mimas to come closer to the planet, it also needs to lose some energy. And the only reason, or the only way this energy can be lost is by releasing it as heat. So this actually explains why Cassini was able to discover liquid ocean inside Mimas. But there's another paper that these scientists released, and it's also in the description below, that connects the interaction of Mimas with Enceladus. In other words, it actually suggests that it wasn't just Mimas doing this, but instead it was a kind of a gravitational union between Mimas and Enceladus that caused both of these objects to, essentially release energy as heat. And in case of Enceladus, it created these beautiful geysers, the picture of which we were able to snap using Cassini, while at the same time all of these geysers and all of these particles being released by Enceladus are also responsible for the formation of the extremely large E-ring that's created by Enceladus. So in other words, if you were to connect this whole story together, it's actually kind of mind-blowing. So these two objects, Mimas and Enceladus, were somehow dragged closer to Saturn by something, we don't really know what yet, and because of this they had to lose energy and thus created a lot of heat. The heat in Mimas didn't really result in much, but the heat in Enceladus created these geysers, creating the E-ring, and thus also creating the mysterious and beautiful gap known as the Cassinian division. Now, altogether, this story is quite amazing and is actually very scientifically sound. There's a lot of math behind it, there's a lot of valid actual observations, but most importantly, it provides us with a very important understanding of gaps in rings. If we actually detect a very large gap in the ring of an exoplanet, what this may suggest is that something similar may have happened there. So an object like a large moon, or potentially almost like a planetary-sized moon, could have been moved closer to a gas giant, releasing a lot of heat, forming an internal ocean, and thus creating a world underneath, potentially habitable world, potentially life. So this is a huge discovery. It suggests that a lot of those rings we've discovered around other exoplanets, with the most famous one being this huge giant about which I've talked about a few years ago, J1407b, where we've discovered huge rings and a lot of gaps. Now, recent analysis suggested that some of these moons may not exist, but because there are so many gaps, there are actually possibilities of discovering a lot of moons on the outskirts of these gaps. In other words, we need to look at the resonance, and we need to try to find more relationship between resonances and formation of these very large gaps in rings. So this discovery now means that we could potentially discover exomoons by just looking at the gaps in rings and then analyzing the area where they might be located, thus actually maybe even seeing them. But according to this study, the modern-day Mimas and Enceladus are moving away from Saturn, and so in the next 40 million years, they will most likely close the gap again, and so the Cassinian division may not actually exist anymore. But for now, this is a brilliant discovery, a very, very interesting analysis, and definitely solves the mystery of the Cassinian division once and for all. Hopefully in the next few years we'll also discover some exoplanets with rings where we can test this idea and this hypothesis, but for now I'm actually pretty excited that we were able to finally explain once and for all what may have happened and how all of this led to both Mimas and Enceladus getting this unusual ocean that they have today. And most importantly, all of this connects with the E-ring and the creation of the beautiful geysers on Enceladus that were discovered by Cassini a few years ago. Hello wonderful person, this is Anton, and you're looking at the beautiful moon Titan, the moon of Saturn. Today we're going to be answering a question of why is it that this is actually the only moon, or really one of the two objects in the entire solar system that seems to have a stable atmosphere on the surface. How come none of the other planets except for Earth and pretty much none of the other moons have anything remotely similar? This right here is the Cassini craft on September 15th, 2017, when it plummeted into the atmosphere of Saturn. This craft is the reason we know so much about both Saturn and Titan, and actually had a small partner attached to it that ended up landing on the surface of Titan and actually took some amazing photos. But all of this was mentioned in some of the previous videos. Today we're really focusing only on one thing. We're focusing on trying to understand how Titan, which is a moon that's way smaller than our planet Earth, is actually able to maintain a relatively thick atmosphere that extends even higher than the atmosphere of Earth. The atmosphere here extends up to about 1,000 kilometers, and the actual pressure on the surface of this moon is about 1.5 atmospheres, meaning that it's about 50% more than the atmospheric pressure on the surface of Earth. This atmosphere is also, just like the Earth atmosphere, predominantly made up of nitrogen, and the other 2 or so percent are usually things like methane, ethane, and a few other components. Earth atmosphere, on the other hand, is about 75% nitrogen, and the rest is oxygen and CO2 and some other things. So here we even have a tremendous amount of nitrogen, just like on Earth. And what is really interesting about this particular moon is that it resembles Earth in many different ways, including of course things like lakes on the surface that we've been able to detect with this radar that you see right here. We've also found all kinds of geological and atmospheric activity very similar to planet Earth, and all in all it has a tremendous amount of secrets that we're still yet to discover. There's even this vortex that we've detected a few years back. So, okay, so the atmosphere, how is it able to maintain this? Because none of the other moons that have a similar interior structure, meaning that if we look inside of this moon, we'll find things like a relatively large liquid ocean, we'll find a really thick water ice structure on top, and we'll find more ice and also silicates on the bottom, and not very much iron. In terms of structure, it's actually very similar to other moons, like for example Ganymede, and the actual moon itself technically should not really have any atmosphere, because if we compare this to other typical moons, let me actually just place a few here so you can see them in comparison. So here's our moon, here's Io, Ganymede, Callisto, and let's also place Europa. So these are sort of the most popular moons. None of the other moons have anything on the surface. There's very, very, very little in terms of what's known as an exosphere, and that usually refers to a very thin layer of molecules, but not an actual thick thing that you see right here. So to answer this, we actually have to think about the molecules present on the surface, and also we need to try to think about objects like Mars that used to have thick atmosphere that was then lost for one reason or another. By answering the question of why Titan has atmosphere and Mars doesn't, we'll actually be able to understand how atmospheres are maintained and how atmospheres can even be created on objects like Mars. So to start answering this, we're going to also place Earth here, which is going to be a gigantic planet in comparison to everything else, and look at what's happening here. So Earth atmosphere has a tremendous amount of nitrogen, but also oxygen, and today we're almost certain that it's the magnetosphere of Earth that essentially protects the atmosphere of our planet and prevents it from evaporating, and we believe that that's why Mars doesn't have atmosphere anymore, or has very thin atmosphere of CO2. Essentially, it lost its magnetosphere and it was slowly stripped by the sun over time. On the other hand, Mars also has a lot less mass and thus less gravity. But then again, so does Titan. Titan's gravity is even less than Mars. And just like Mars, Titan also has no magnetosphere. So for a very long time, some scientists suspected that maybe Saturn is actually protecting Titan by enveloping essentially all of the moons here with a very thick magnetic field. But that's not really what's happening here at all. And as a matter of fact, the answer is more chemical than it is related to the magnetosphere. So going back to what we know about Titan and Earth, we know that they have one thing that's pretty much in common, and that's nitrogen. Both objects have a tremendous amount of nitrogen on the surface. And on the other hand, Earth also has oxygen, but Titan has no oxygen, or at least none we've detected so far. And that's really the biggest hint here. The real reason is that oxygen is actually relatively unstable when it's exposed to the solar radiation. Specifically, here is what the molecule of nitrogen looks like. This is N2, it has a triple bond, making the molecule relatively strong. And here is O2, oxygen, that has a double bond, making the molecule slightly less strong. Now, interestingly, oxygen is slightly heavier than nitrogen, so technically speaking, the molecular weight itself is not enough to keep the oxygen on the surface of different objects. As a matter of fact, even if we put a bunch of oxygen onto the surface of Titan, it will most likely not stay here very long. So molecular weight is one thing, and the molecular bond is the other. If we also look at the actual molecular weight and compare it to the gravity of the object, and this is actually something known as Jean's law, we can actually see, or draw in a sense, a kind of a graph where you can determine what object in the solar system can maintain what type of a molecule. So for Earth and Venus, they can maintain everything including water vapor, ammonia, and methane. But they cannot maintain helium or hydrogen. That's why our planet Earth has a tremendous cloud of hydrogen and helium around it. And helium for the most part escapes and never returns. However, the gas giants and ice giants have no problem maintaining these, and for the most part they are made out of hydrogen. Then we have objects like Titan and Mars, and also Ganymede is on the list here, that can technically maintain oxygen and nitrogen, at least according to the molecular weight. And so in that sense, technically both Mars and Titan should have a relatively similar atmosphere. But for some reason or another, Mars never really got a tremendous amount of nitrogen like Earth and Titan, but it used to have oxygen, and we're pretty sure they used to have oxygen because it turned red, and the redness of Mars comes from the fact that it got oxidized by the oxygen. This is most likely iron oxide. And so this oxygen was there, but is not there anymore. And so something must have caused the oxygen to break its bond and connect to other molecules. And this something is, of course, the solar radiation. Here's what the sun's radiation spectrum looks like. And for the most part, as you can see, our sun emits mostly visible light and some infrared and a little bit of UV light. But the UV light it emits is actually relatively soft. It's not very strong. It doesn't really emit almost any hard UV light. And it just so happens that the molecule of oxygen is highly affected by the soft UV light. It can actually be broken up by the soft UV, but the molecule of nitrogen cannot. It needs to have hard UV light for it to break. So it's the solar radiation that breaks up the oxygen molecules, creating other molecules or letting oxygen escape into the outer space and basically disappear. And yet at the same time, it's the lack of hard UV light from the sun that allows nitrogen to survive on pretty much any object without any concern for its stability. So in other words, you could technically have nitrogen on every major moon and every major planet, and it would not really disappear, because sun's radiation is just not strong enough to break, for the most part, the nitrogen molecule. On the other hand, the system of Saturn is also pretty far away from the sun. It's over 9 astronomical units away from the sun, meaning that only about 1/80th or even less than that of the solar radiation reaches Titan and reaches Saturn compared to Earth. In other words, if you were to stand on the surface of Titan as opposed to standing on the surface of Earth, you would only receive about 1/80th of the radiation. So the actual strength of the solar rays here, even if it's hard UV rays, would not be really that strong. It would not really affect the actual atmosphere of the moon or the planet that would be here. So this is really, or these are the main two reasons why Titan has such a thick atmosphere and why it's able to maintain it so well. So the reason number one being that the solar radiation is just not strong enough to break up nitrogen molecules, and also it's really far away from the sun. And two is that the actual molecule of nitrogen is heavy enough to be easily maintained by the gravity of this moon. However, it would most likely not be able to maintain oxygen for a very long time, specifically because oxygen would definitely be broken up without any magnetosphere. And at the same time, this actually creates a kind of a mystery and a kind of an unanswered question that we still haven't really been able to answer. Why is it that only Titan and Earth have such a thick nitrogen atmosphere? Where is nitrogen on Mars? Where is nitrogen on the other moons like Europa, Io, Ganymede, and Callisto? So why only these two objects in our solar system have nitrogen and have such a thick layer of it? And some scientists think that maybe it's actually because in the last few billions of years, both objects received a tremendously large collision from possibly some sort of a planetary body or a very, very large asteroid that delivered all of this nitrogen. And the other objects just didn't really get to receive that collision. But that's actually still not entirely proven or really has any kind of evidence, because we haven't really found these nitrogen asteroids or nitrogen planetary bodies. So for all we know, it could have actually been there from the beginning, and why, we don't really know just yet. But we do know that it's very, very important, because nitrogen is absolutely essential for life, and it's basically one of the most important molecules out there. Both Titan and Earth got really lucky with the source of nitrogen, and it's also very possible that because of this, Titan has some really crazy mysteries on the surface, including potentially unusual life. But that's of course a story for another day. Anyway, so on that note, hopefully now you know a little bit more about why only Titan and Earth seem to have atmosphere and why other objects don't, and also why Titan has not lost its atmosphere even though it's been billions of years. For the most part, both planets will probably be able to maintain their atmospheres for quite a long time still, for as long as Earth maintains its magnetosphere, and for as long as Titan basically stays in the same region of space and the sun doesn't change too much. If one day Earth loses magnetosphere, it's probably going to also lose oxygen, but nitrogen is probably still going to be here. So the atmosphere of both of these objects is pretty safe.
Hello wonderful person, this is Anton, and in today's video we're going to talk about the recent paper from 2016 that may have solved the mystery of Saturn rings, specifically how these rings may have actually been formed. So this beautiful planet, Saturn, is probably one of the most beautiful planets in our solar system, and of course it's the most famous planet for its huge rings. Now, you may have not known, or you may have known that other gas giants also have rings, but they're not as large as Saturn's rings, but they do have them. They do have these rings orbiting around them as well. And so far, the theories were quite diverse. There's quite a lot of theories behind the formation of the rings, but one of the more compelling theories is that it was either based on a moon by the name of Veritas that used to orbit around Saturn, and then because of the proximity to Saturn and because of the strong gravity of Saturn, this moon essentially fell apart. And it's not really doing that right now, but let's move it a little bit closer toward the Roche limit, the concept which I will discuss in one of the future videos, but let's just move it a little bit closer and make it fall apart. So there it is. I think it's increasing in size, it's slowly changing its shape because it's actually being destroyed by the tidal forces of Saturn. So this was the most prevalent theory, where basically these rings were formed from a moon that used to be there. But we then realized that maybe this is not as simple as this. Maybe, just maybe, this was actually formed from the beginning. As a matter of fact, maybe these rings were actually formed when Saturn was formed, and just some of them were too close to Saturn, so they never solidified, never became moons, like for example Titan, which was far enough to actually solidify into an actual object, but the objects that were too close to Saturn never got to do that. And some theories suggest that maybe there was a moon that was actually struck by an asteroid or something very large, and then it fell apart and created the rings. So these were the theories so far, but none of these theories explains one thing. So we know that the rings of Saturn actually mostly contain like 95% ice. Now Saturn is actually heating up, but that's because of the friction and tidal effects, as well as the matter falling on the surface of Titan from this moon I placed earlier, but let's just ignore that for a second. So we know that the majority of these rocks that orbit Saturn, that are right here, most of them are basically ice. 95% of it is ice. The mystery was that, well, if you actually look at the rings of other objects, like for example rings of Neptune and Uranus, which both of them actually have smaller rings, but they do have rings as well, these rings are much darker and seem to contain mostly rock, and some may even contain metal. So for both Jupiter and Saturn, the rings seem to be basically ice formed. They seem to have only ice formation. But Uranus and Neptune, which here doesn't actually have rings, but it does have rings in reality. So let's just look at Uranus instead. So both of these planets seem to have more darker, more silicate-based rings, as opposed to being water-based. And as of now, there was actually no explanation for this inconsistency until the paper from 2016 from a Japanese University of Kobe that basically suggested that maybe, just maybe, these rings were formed in a very different manner. And as a matter of fact, I'm going to try to show it to you how they were formed. So here's actually the extreme situation of that simulation. So Saturn has this really large object of Neptune coming closer to it, and because of the interaction of gravities, specifically because of the tidal forces that Neptune experiences when it approaches the so-called Roche limit of Saturn, what is going to happen is that Neptune is actually going to fall apart and create a kind of a ring formation around Saturn. And you'll see that happening after I run the simulation for a little bit. You can already see it happening right now. So the rings will actually start forming around it because this object fell apart due to tidal forces. And so what this paper from Kobe University suggests is that both Saturn and Jupiter earlier on experienced a lot of close calls, not collisions, but close calls with very large objects, specifically probably objects that would be similar to Pluto, Ceres, Pallas, and so on, basically dwarf planets. So maybe, just maybe, several billion years ago, during the so-called late heavy bombardment, which is basically when Earth received a visitor that essentially created the moon through a very large collision, maybe Saturn and Jupiter also received these close calls that didn't really collide with the planet. And I think this one will actually collide, so I may have to increase the speed here to about 25 kilometers per second. So it was basically these close calls from various dwarf planets that passed by that didn't collide with Saturn, although they all seem to be colliding right now, but they didn't really collide. They basically passed through, and because of the interaction with the gravity of Saturn, created this ring formation that we have around it. And because these objects contained both rock and ice on it, for Jupiter and Saturn, due to their lower density, only the ice escaped. Only the ice essentially formed the rings. Whereas for Neptune and Uranus, because they're actually a lot more dense than Jupiter and Saturn, they were also able to capture various rocks. So let's see if we can actually do it right now. Or actually, let's just place one of them in sort of a orbit around Neptune and see what happens due to the interaction with the planetary tidal forces, or basically planetary gravity. So with time, this object will actually form rings because it will fall apart and create a bunch of particles orbiting around this planet. So using the computer simulation, these scientists from Kobe University were able to basically estimate the possibility of these various objects, such as, for example, Sedna here, passing by the orbit of Jupiter and Saturn, and through the interaction with the strong gravity forces, basically releasing enough material for these planets to acquire their own rings. And to be honest, it's actually a very compelling theory. It's a theory that kind of explains the differences in composition of rings between Saturn and, of course, Neptune and Uranus, which are right here. And at the same time, it also explains why and how these rings may actually form in other parts of the galaxy. So many exoplanets seem to have these unusual rings too, but we still have no idea how they formed. But I guess one thing that it doesn't really explain is why the rings actually seem to orbit with the rotation of the planet. So if this were actually true, if the actual rings were formed through a close-by passage of a dwarf planet or any kind of a smaller, not as massive object, why is it that they seem to orbit in the same direction as the rotation of the planet? Now, it may actually not seem strange until you actually look at the orbit of Uranus, which actually spins in sort of a very strange direction. As a matter of fact, it's almost 90 degrees to the plane of orbit in our solar system. So had the object actually come from this direction, it would make sense. But had it come from this direction, it wouldn't really make sense why it would have rings spinning in the same direction as its plane of rotation. So in other words, most of the minor planets would probably come from sort of this direction right here. And for them to actually create this sort of an orbital ring around the planet, they would actually have to come from the other direction. So it still is maybe not the best explanation we have, but it's definitely a good explanation for why the composition of these rings is so different from one planet to another. Hello wonderful person, this is Anton and welcome to What the Math. In this video we're going to try to talk about a very common question that I get on this channel, and this is basically in regards to the rings around different planets. Many people have been asking me to talk about why planets like Saturn seem to have rings, but other planets do not have rings, or do they? Alright, so here we are in the ring system of Saturn. This is in Space Engine, of course, and if I actually slow this down to the point where you can kind of see what's happening, you will be able to kind of even see the little particles orbiting around Saturn, because that's essentially its rings. Now, here is one. Oh, here we go. You can kind of see the tiny particles. Now, what you may not be aware of is, of course, that every single gas giant in our solar system has a ring system. It just, the biggest one is around Saturn, and this is why this is stereotypically known as the ring planet, even though other planets do have them as well, and I'll show it to you in a second. Before we go though, let's actually, let me just quickly tell you about these rings in particular. So very recently, specifically after the Cassini mission, we've discovered that these rings are actually ancient. We used to think that there might be new, there might have been, you know, formed in the last few million years, but even though they actually are new particles, it's because they actually collide with each other and they reform every single second. So all of these particles are new, but the actual ring system has been around Saturn since the beginning of the solar system. So these are absolutely ancient. Anyway, so we now are going to escape and take a look at other rings as well. Let's start with the first one around Jupiter. Now, just to kind of start answering the question about why is it that, you know, other planets don't seem to have rings. Well, yes, gas giants do have them, and you can kind of see the very, very vaguely, obscurely visible ring system that I'm trying to slowly approach so you can actually see it. So, yes, other gas giants have them as well, but the terrestrial planets don't. And the reason for this is because of two things, really. One is that for a ring system to form, which you can kind of see now, hopefully. I don't know if you can, but it's right there. It's very barely visible. So for rings to form, first of all, they have to be a little bit farther away from the sun. The terrestrial planets are close enough for all of this gassy stuff, which actually basically is things like tiny, tiny rocks and pebbles and dust, but also things like ices, water ices and organic ices, for them to be basically, you know, here. Oh, hey, this is more visible if I actually turn around. There we go. That's what I was looking for. So for this to actually be in this region, it has to be a lot farther away from the sun. So the sun, that's right there, has quite a lot of power. It actually can easily push away particles away from a planet, which it often does in cases of, you know, Earth and Venus. Like, for example, Venus is constantly losing its carbon dioxide that is basically being ejected by the sun, and then the solar winds take it away farther into the solar system. So even if there were rings around Venus and Mercury in the past, they were blown away by the sun a long time ago. But Saturn and Jupiter are far enough that they can easily maintain this. So that's the first reason. And the second reason has to do with density. Jupiter, Saturn, and other gas giants, they're not very dense, and we're actually going to go check out the other gas giants, starting with Uranus. They're not very dense, and our planet Earth is very dense. It's as much as 5 or 6 times more dense than most of these gas giants. And because of this density, the so-called Roche limit, about which I've previously talked in the past, but I'm going to also talk about in one of the future videos, is basically responsible for creating these rings. And the rings around Uranus are really difficult to find there. They are actually, I think I finally found them. They're very, very tiny. There are, I believe, 13 of them. And they are very, very dark, which is why it's so difficult to see them. So there is one of them. I'm going to try to approach it. So the Roche limit is actually responsible for forming these rings and for basically maintaining them. Roche limit refers to the fact that if you approach a planet relatively close and you're a smaller object that's a little bit less dense than this planet, you will fall apart and you will turn into dust. And this is actually what's going to happen to Phobos in the future. When it approaches Mars, it is going to at some point fall apart and become a ring. So Mars will eventually have a ring system, and it will obviously have it for quite a long time until Sun blows it away again. Now, let's actually take a look at Phobos really quickly, in case you have no idea what I'm talking about. And so this is Phobos. This is one of the moons of Mars. I'm going to zoom away from it for a second just to show you how close it is to Mars currently. So here is the orbit of Phobos around Mars. And so in the next few million years, it's going to approach close enough to Mars that it's actually going to fall apart and become a ring system. And so Mars will have rings in the future, and it did have them in the past, because we now are kind of almost positive that both Phobos and Deimos, the two moons of Mars, were actually formed from a collision with a very large object. when a large object collided with Mars. And this is actually how Earth was how Moon was formed as well around Earth. And when this happened, there actually was a very large ring system around Mars and also around Earth when Earth received a collision from so-called Theia. So it's very likely that both Mars and Earth did have rings in the past, but with time they disappeared, either, you know, falling back into the planet or turning into these two beautiful moons. So the moon known as Phobos and the other moon known as Deimos, which is right here. So yeah, and the rest of the dust was blown away by the sun into the outer solar system. Alright, so that's essentially one of the main reasons why there are no actual rings systems around the inner planets anymore. And so it's very possible that there were some before, but they're now gone because of the sun action on them. And let's actually take a look at the last ring system around Neptune. Now, the third, I guess, reason is because of the origin of these rings. So many of these rings have a very, very unique origin, and it's actually very different depending on the planet that you visit. So, in case of both Neptune and Uranus, and this is of course Neptune, we have actually no idea just yet why there are rings here. These rings are very, very different from the rings of Saturn and Jupiter. As a matter of fact, they're almost entirely different. They're very dark. They contain mostly organic materials and a little bit of dust here on Neptune. Uranus doesn't actually have any dust. It's mostly organic materials. And this is basically things like soot. So, you know, ashy, dark-looking material that's just kind of orbiting around these planets. And it could have come from pretty much anywhere. It could have been a collision. It could have been maybe some kind of an eruption on one of these moons that orbit around Neptune and Uranus, but we don't really know just yet. We do know where other rings came from, though. So, for example, in case of Jupiter, we are kind of positive that most of these rings came from collisions with moons of Jupiter. So, for example, there is a moon right here called Thebe, and so when this moon received a collision, some of its dust escaped and created a ring that is very close to it now and orbits in the same sort of orbital parameters. Same thing happened to the other rings, and some of these rings were formed from volcanism, and this is actually more common with Saturn. So Saturn has a very, very wide variety of rings. So inner rings here are made out of ice, and this is actually very likely has been here forever because this would have become a moon. But because it's within the Roche limit, it never really had enough sort of opportunity to become a moon, and so it remained as ices. Some of these other rings were formed a little bit differently. Specifically, there's actually rings that you don't even see here. And some of those rings were also formed from collisions with the moons, but the majority of them were formed from the volcanism from various moons around Saturn, specifically cryovolcanism. So basically volcanic eruptions of ices and water ice. And the most famous ring for that is also known as E-ring. E-ring was actually formed entirely from volcanic eruptions from one of the moons, and I believe it is the moon right here called Enceladus. Now, unfortunately, you don't really see the ring in the game because it hasn't really been added yet, but there is a very, very large, although not very visible because it's kind of thin, ring that goes right here, and this is called the E-ring, and it's formed by the eruptions, the cryo eruptions, the ice eruptions of this beautiful icy looking moon, which is something we've talked about previously, and it's a pretty awesome place that has a really, really large liquid ocean underneath. And so that's essentially how many of these rings were formed. But what you may not be aware of is that there's actually other ring systems around other objects as well. So this is, for example, another Saturn moon called Rhea, and Cassini mission suggested that maybe there is also a ring system here that we don't really see. Because of the distribution of magnetic field around this particular moon, there seems to be some kind of an invisible formation that may suggest a ring system. Now, whether it's a ring system or something else, we might discover sometime in the future, but it's possible for moons to have rings as well. Obviously from different types of collisions or possibly from volcanic eruptions as well. But we know for a fact that there's at least one asteroid that has a ring system as well. And this asteroid is known as Chariklo. It's about 300-ish kilometers in diameter. And you can actually see this ring system right here. So Chariklo is a very well-known example of ring systems that are outside of the planetary system. So there it is. There's actually 2 of them, and they actually even have unofficial names. They're named after the rivers in Brazil, and I'm going to mispronounce it for sure, but I believe this one is called Oiapoque, and I think this one is called Chui, and I'm sure this is not how you pronounce it in Brazilian Portuguese. Anyway, so that's essentially the rings, the ring systems and origins of the rings, and you can probably guess that these 2 ring systems were formed from some sort of a large collision with this flattened but beautiful asteroid called Chariklo. And it's very likely that many other objects, including asteroids and including moons, may actually have various ring systems around them. And so now hopefully you know a little bit more about rings and how they're formed and why inner planets don't seem to have them. And so once again, it's really because they're kind of close to the sun and because they used to have rings, but they just don't have them anymore.
Hello everyone, this is Anton and welcome to What the Math. In today's video we're going to be taking a look at various amazing photos that were taken by the Cassini probe in the last few years, and we're going to do all of this by basically flying around in space engine and looking at Saturn as well. So this probe that I'm talking about is called Cassini, and it actually spent most of its lifetime flying around Saturn system and snapping some really incredible shots, and I'm going to try to show you some of the best ones. Now, most of these photos came from NASA, and I actually found them on the website called space.com that often publishes these websites from NASA directly. So all of the credit goes to both NASA and of course space.com. And Cassini probe has actually been around Saturn since 2004, and it took it about 7 years to get to Saturn. And its original mission actually was to release a Huygens probe that then landed on Titan in 2005 and took some photos of the surface of Titan as well, but we're going to discuss all of this in more detail later. And this mission was actually a joint project between NASA, European Space Agency, and also Italian Space Agency. And at the end of this mission, specifically in 2017, which for me is only a year away, this mission, or the Cassini probe, will actually crash into Saturn and send back some of its last telemetry, specifically regarding Saturn's atmosphere and possibly some other information that we would like to know about Saturn. And the picture you're actually looking at right now was shot from a distance of about 2 to 3 million kilometers away from Saturn, and all of these photos were actually taken in the last few years of its missions, where basically NASA decided to focus on photography rather than doing anything else. And so let's actually start with this typical photo of Saturn that was snapped by NASA in February of 2016, and you can kind of see the gas giant with its inner rings and its unusually shaped polar hexagon that is actually better seen here. And this detailed picture, specifically the picture right here that uses ultraviolet and infrared light, shows you the interestingly shaped mega-sized storm that can actually fit 4 planets Earth inside of it. And it's actually thought to have been formed by several smaller storms on the inside that cause it to create this almost perfect hexagon in the northern region of Saturn, specifically at its polar region. And just like the huge storm on Jupiter, this particular storm has actually been around for a very, very long time as well. Now here's another picture, and this is what Saturn rings look like from the edge side, and you can kind of see the details by the shadows that are formed by these rings on the surface of Saturn. And as you can see, they're basically almost perfectly circular in shape and very, very thin as well. And here's a close-up of the gas giant with its moon Enceladus in the lower left corner, and this moon is not as small as you think, even though it is spherical in shape, which is a telltale sign that the moon has enough mass to actually turn spherical. And I'm gonna show you a few more pictures of Enceladus later on, but here's actually a cool shot of the rings with 3 other moons, specifically here Titan, Hyperion, and Prometheus. Now, can you actually guess which one is where? And I think I'm not going to spoil you with the answer of which moon is where, and let you figure this out yourselves. Now, this shot right here is actually quite unique, and this is a pale blue dot, but although you may assume right away that this is Earth, it is actually Uranus, which is somewhat closer to Saturn than Earth, and obviously much, much larger in size, so it's much easier to see.
And here is a photo of Iapetus, one of the bigger moons, specifically third biggest in size. And this shot shows you how different in brightness two of the hemispheres are. So one side here is extremely dark and one is very, very bright. Now we're not entirely sure why yet, but this is what it looks like. Now most of the pictures I've showed you so far were black and white, and here's actually a picture of Saturn seen in its natural color. This image is from July of 2013, and it shows you the Saturn northern pole with its hexagonal storm as well. And another color image shows you a slight blue color that becomes more apparent during the winter season on Saturn, which of course lasts for at least 8 years or possibly even longer. And the blue color is actually thought to be formed because the winter side doesn't really get enough ultraviolet light from the sun anymore, so the gas reflecting yellow color becomes less active and the natural blue color comes out instead. Alright, let's come back to the mysterious snowball moon called Enceladus. This is a moon covered in snow and ice and possibly with liquid water on the inside. Here's actually a better close-up of Enceladus that shows some of the textured features on the surface, and another shot showing the effects of cryovolcanism, specifically ice eruptions, that often leave this moon. And this is actually how one of the rings of Saturn is produced, because it's entirely formed from these eruptions from Enceladus. And lastly, another photo showing some more detail on the surface, indicating craters that looks somewhat different from the ones on the moon, because basically here the surface is all water ice. Now this really cool shot shows the two largest satellites together, Rhea and Titan, in their true color. This was actually shot in December of 2013, and you can also see the atmospheric layer of Titan in the shot, which of course makes this moon one of the more interesting destinations to visit in the future. And here's a shot suggesting that Titan has a huge storm as well, so it might be quite an active planet with both atmospheric and surface-based activities. And when I say planet, I actually mean the moon, even though technically, in terms of atmosphere and in terms of activity, it may seem like a planet. And this shot indicates the biggest hydrocarbon lakes on Titan, with their names being mythological creatures such as, for example, the infamous Kraken. This is so far the only moon we've found that has these huge liquid basins, even though it's not really liquid water, but it is liquid hydrocarbons. And another shot of Titan and Saturn, although this time from behind Titan, and although here Titan looks really big and actually kind of close to Saturn, it's actually quite far away and much smaller. In this photo, the effect is actually formed by the extreme zoom of the lens. And this unusually artistic shot shows Saturn on the left that's covered in complete darkness, and three of its moons, Rhea in front, Enceladus to the right, and Dione to the left. And this shot was actually taken back in 2011, and it's probably one of my favorite pictures from Saturn. And this here is an unprocessed photo of another moon called Dione, with a really interesting shot of the surface at a distance of only 8,000 kilometers, meaning that the probe passed really close to this particular moon. And here is an interesting close-up of Tethys, although to me personally doesn't look much different from Dione, which is not surprising of course, because many of the moons here contain the same materials and are made up of the same stuff, and actually experience the same elements of space as well, such as for example collisions and the gravitational effects of Saturn. And Saturn's atmosphere is actually very active and very, very powerful, and this is one example of such power, a huge electric storm size of our planet Earth that can actually be seen better on the enhanced picture to the right. And all of this is essentially huge amounts of lightning. And rings themselves are also very, very fascinating, and here you can see how highly ordered they are and how many of them have very, very specific textures and are different in terms of particle size and even form specific and very unique gaps between each other. Now let's actually end this with this really interesting shot of Titan obscured by the rings of Saturn. Now this is a beauty to behold and definitely gives you an idea of how marvelous and how gorgeous Saturn's system must be. And to me, I think we should totally forget about the mission to Mars and instead focus on the mission to Titan, because this is where we want to be. This is probably one of the most beautiful places in our solar system. But the last shot is going to be, of course, the shot of a beautiful planet Earth. This is a pale blue dot Earth, and even our moon as they appear from Saturn or from near Saturn. And here's actually a close-up where you can kind of see what Earth and moon look like if you were to zoom in on that picture. Hello everyone, welcome to Saturn and welcome to What the Math. This is Anton, and today we're going to explore Saturn and specifically talk about 5 unusual facts about Saturn's moons that you may have not known about before. We're going to take a look at those 5 different moons and talk about what is so unusual about this unusual planet and of course its unusual satellites. Now this right here is the first satellite on our list. Actually, there's 2 of them we're going to take a look at, and this one is called Janus, and its companion is called Epimetheus. Now, you don't really see Epimetheus, but it is in the same orbit. As a matter of fact, it is the only other moon in the solar system that actually occupies exactly the same orbit as its partner. Let me show you what I mean. Now, this right here is Janus, and on the other side currently, you have Epimetheus. Now, these 2 satellites surprisingly occupy exactly the same orbit. As a matter of fact, they actually do come relatively close to one another at some point, but they never collide, and they never will. And the reason why they'll never collide is very interesting. Over the millions and billions of years of orbiting around Saturn, they've created a kind of pattern also known as a horseshoe orbit, where they kind of approach each other, but then they separate again. I think the best way to explain this is to actually show it to you in Universe Sandbox 2. And I guess if you accelerate time here, you'll get to see that, well, first of all, they do have almost exactly the same orbit. It's only different by about 50 kilometers. And over time, they kind of approach each other relatively close, and then they separate again, and then they approach each other again, and they separate again. Now, that's actually very interesting, and we haven't really seen any other objects in our solar system that do that. But here, what's interesting is that when Janus was first discovered, we couldn't really figure out what's going on because its mass constantly kept changing it until we realized that Janus and we actually were looking at 2 different rocks in the same orbit. So Janus and Epimetheus were 2 different objects, and their mass is different. And when the astronomers were looking at them, they were basically looking at 2 different things. And once they realized that, and this actually happened when Viking 2 mission came to Saturn and flew past Saturn and took some pictures. When we realized that it's 2 different objects, we didn't really know how to explain it at first until further analysis showed that it's actually possible to have an almost exactly the same orbit for 2 different moons or 2 different objects, even if it was a planet and another planet. So we could technically have other objects orbiting with our planet Earth, for example, and as a matter of fact, we actually do have several asteroids orbiting in a very similar orbit to our planet Earth, and they do create this kind of a horseshoe orbit with our planet. But other than these asteroids, we actually haven't found any other objects in our solar system that have this unusual pattern. Anyway, number 2 is something that we actually have only seen very recently. So as a matter of fact, we've discovered that Saturn has another very, very large ring, but it's very difficult to see it, and it doesn't actually show in the game, but it is out there, and it's possible to see it in infrared. And this particular ring is actually formed and created by this moon right here called Iapetus. Or actually 2 moons, Iapetus and Phoebe. They, as they orbit around one another, they create this kind of a ring at a distance of about 128 times the radius of Saturn. So it's basically this far away, and it's right around here. And actually, here's a way to show it to you in Universe Sandbox 2. So basically, this ring right here is formed by Phoebe and Iapetus. And this is probably the largest and the farthest ring we've seen so far in our solar system, and actually was quite an unusual discovery when we just found it. Okay, and fact number 3 are these 2 other moons called Pan and Atlas, and I'm going to try to find them. They're actually not very large, so I may have to just search for them here. And unfortunately, in the game, they don't really look exactly like they should look, but this is what their real shape is. They are basically saucer-shaped. And we didn't really know why they were saucer-shaped until we realized that what we see here is a formation of rings around moons of a ring planet. Basically, both Pan and Atlas developed these rings over time, and these rings were formed from the rings of Saturn. They basically deposited on the on the lateral side of these two relatively small moons of Saturn. And as the dust was kind of deposited around the moon, it created this kind of a saucer shaped that is very, very unusual and very unique in our solar system. But basically it was formed because all of this dust collected on the sides of these moons. So this is Pan, and here is Atlas. Now, this doesn't really look exactly like it should once again, but it is a more saucer-shaped object, as you see on the screen right now. And this was actually very recently explained by the scientists from University of Paris. They've simulated the creation of these saucer shapes, and it was actually a very unusual discovery, and they've published a paper about it, explaining that basically this saucer shape is possible if you have a moon that's orbiting within or very close to the rings of a ringed planet. And anyway, let's go to number 4, and number 4 is a moon called Hyperion. And once again, this moon is not exactly well represented in this game, but the surface of the moon kind of does look like that. As a matter of fact, all of these dark spots that you see are actually very, very dark caverns that go through the entire moon. And this moon is actually very large. Its diameter is 320 kilometers, and it has a large crater here somewhere as well. That's about 120 kilometers large. But what's interesting about Hyperion is that it's essentially 46% empty space. It's very, very porous. It's essentially Swiss cheese-like object where you have almost nothing on the inside, and there's a lot of these really long, really large caverns that go through the entire moon. And so you could actually fly through this moon in some sort of a spaceship and come out on the other side very easily, because some of these craters are very, very large, and some of these caves are probably the biggest caves we have in our solar system. And this particular object actually has been discovered over 150 years ago, specifically in 1848, and it was the first non-round moon to be discovered ever. And in terms of composition, it really just has a bunch of rock in it, but for the most part, it's actually all ice. It's all water ice, so if you were to melt this, it would basically leave you with a tiny rock that would possibly not even have any caves left in it, because most of these caves are formed by frozen ice. And object number 5 is Enceladus. Enceladus actually deserves its own video, but I'm going to talk about this sometime later. And the reason why Enceladus is so cool is, well, first of all, because of its brightness. It is the most reflective object in our solar system. It reflects a ridiculous amount of light. Over 90% of light, actually almost 100% of light, is completely reflected from the surface. So looking at this object may actually hurt your eyes, in real life at least, because it is very, very, very bright. But this is also the reason why it is also very, very, very cold. The temperature here is ridiculously cold, so it's basically a very large ice chunk. And what's really cool about this object is that we actually have discovered that it has something called cryovolcanism. Basically, it has volcanoes, just like our planet Earth, but instead of plumes of lava, it has plumes of water and water ice spewing from within the planet, where we think there is actually liquid ocean underneath it. So this is a multi-layer moon. You have really thick ice on top, you have liquid ocean underneath all of this, and then somewhere in the middle there's probably a rocky center as well. And what's really, really interesting about this ice and this cryovolcanism is that this particular moon creates another ring of Saturn known as the E ring. So the E ring of Saturn is formed entirely from the volcanoes or cryovolcanism of Enceladus. Basically, all of this ice and water that's spewed out from within the moon is deposited around the Saturn, and it creates the E ring around it. But not all of it goes into the ring. Some of it falls back onto the surface of the moon, and it returns back as snow, ice, and then possibly becomes liquid water if it goes underneath as well. And this is actually one of the few objects in our solar system that is also geologically active, meaning that it actually has things exploding, things moving around, and possibly even some sort of plate tectonic-like activity on the surface, but most of it is caused by the interaction with Saturn, and specifically the tidal forces from the strong gravitational field of Saturn. So because this object orbits around Saturn, as it orbits around Saturn, the gravitational forces of Saturn cause a lot of the internal motion of Enceladus and basically even warm up the insides and possibly even cause the liquid ocean underneath the surface here. So this is a very cool world to visit one day, because we even think that if there is actually life in our solar system, this is a very good candidate for it. And anyway, let's escape Enceladus and go back to Saturn, because I think I'm going to stop this video here. I wanted to kind of talk to you about these unusual facts that you may have not known before, and specifically mention these different moons that you may have not heard about before as well, and give you an idea of how unusual, how awesome, and how really cool Saturn actually is. Hello wonderful person, this is Anton, and in today's video we're going to be exploring the Cassini mission and basically go through the whole history of the mission, talk about the important findings, and use NASA's eyes to discover everything that this mission discovered. So let's actually talk about Cassini-Huygens mission in a little bit more detail, and I call it Cassini-Huygens mostly because there's actually two parts, or there were two parts to this mission. One was the orbiter, which is that thing right here, and the other one was the lander that ended up landing on the Titan and taking an incredible footage, the first basically footage of such object in our database, and essentially we were landing on an incredible moon of Saturn. And you can actually find out more about this particular mission and also watch the footage in one of the videos I made previously by clicking on the link you see on your screen right now. But anyway, let's actually talk about this mission in more detail. We're going to be talking about the whole history, starting from the launch, which actually happened 20 years ago from when I'm making this video, back in 1997. And so let's start with the launch. The Earth is going to render. And here we go, the launch of Cassini from Earth. Cassini left Earth back in 1997 in October, and this was a normal launch of a normal sort of a satellite, a normal orbiter. And the idea here was to launch it from Earth in the direction of Venus. And we're going to actually do a few Venus flybys for the next few years. So this wasn't a direct mission to Saturn. And this is usually done to save on fuel and basically be able to bring more stuff on your actual satellite. So because the satellite was really big, really heavy, it essentially launched from Earth and used several passes of Venus and one pass of Earth to get what's known as a slingshot maneuver, or to do what's known as a slingshot maneuver by basically doing this. So as you fly past the planet that's already moving, you'll actually get a little bit of velocity from that planet as well. So this is exactly what a Cassini mission is going to do. It's going to fly very close to Venus that you see right here. And this happened in April of the next year, April of '98. And as it flies next to Venus, it's going to basically get some velocity and then do this again the year after. And the final slingshot maneuver was next to Earth, and this basically launched it toward Jupiter, where it got yet another slingshot maneuver. So these are relatively complex maneuvers, but we've done so many of them that we actually have achieved expertise in these maneuvers, meaning that you can actually launch an object toward a planet and then use these slingshot maneuvers by expending just a little bit of fuel and then getting quite a large amount of velocity that way. So here was a 1999 slingshot maneuver from Earth. This gave a Cassini mission yet even more velocity, and now it basically is ready to be launched past Mars into the area of here we go, and look at how close it passed to the area next to Jupiter, where it's going to be going next. And so when it approached Jupiter, it actually was able to take some incredible photos of Jupiter, the first such photos we've ever seen. It actually was able to even do a lot of science around the system. So Cassini mission didn't just study Saturn, it also studied Jupiter quite a lot. And this was just on the flyby sort of a trajectory. And it took a lot of photos, it took a lot of data, and was able to even take a few photos of its satellites as well. And this was actually quite an incredible opportunity for us to see some of the things on Jupiter we have never seen before. And this occurred back in January of 2001. So you can see it's passing by Jupiter, getting extra velocity from Jupiter, and then proceeded to its final destination, Saturn. When in 2004, basically 7 years after it left Earth, it is going to initiate what's known as the insertion maneuver. So here you get to actually see what happened. It's going to reposition itself, pointing away from its velocity vector, and it's going to slow down and place itself in orbit around Jupiter. So it's a very complex, very dangerous, yet really cool maneuver. And if you've ever played Kerbal Space Program, you may know how difficult it can be to actually reach this particular area, or how difficult it is to be so accurate about approaching this particular area. And so now we are in orbit around Saturn. And this is going to be our orbit for the next 13 years. We're going to be staying here for 13 years doing a lot of exploration and data. And because this particular probe had something like 2,000 meters per second of delta V, it meant that it can actually, or it could actually navigate and maneuver itself as it needed by changing trajectories just a little bit and approaching various moons and various areas around Saturn quite easily. So this probe actually brought quite a lot of fuel with it, which is why the mission was so heavy to begin with. And on top of that, Cassini actually, let me just zoom into it so I can show it to you. Cassini also had a really interesting plutonium battery inside, so you can kind of see it's right here. This is how it produces energy. So it doesn't actually have any solar panels because it didn't need them. It had the plutonium-based battery that produces quite a lot of energy and would actually last for many decades. So in terms of energy, it was just fine. There's actually two of them. Oh, and one thing I actually forgot to mention, and that wasn't shown in the simulation, is that on the way to Saturn, it passed through the asteroid belt, and it actually passed by an asteroid and was able to take some really nice footage and pictures of it as well. And when I actually say close, I mean like 1.6 kilometers away, so it's still pretty far. And this is actually the picture of that asteroid that it was able to shoot from that distance. So that was a pretty cool opportunity for us to actually snap a shot of an asteroid and even study it a little bit as well. And this asteroid was known as 2685 Mazursky. And you can actually find out more about this asteroid on Wikipedia, or just by going to any of these links in Wikipedia. So if you actually want to know what we learn about it, go and check it out. But long story short, not a lot. We didn't have enough time to study it. Now the next important event is right here. This is the Huygens separation. And Huygens is actually this little umbrella thing here that just sort of separated. And it's going to go and land on Titan. It has its own battery, chemical battery that it's going to be using, and it has its own camera, and it's going to be snapping shots and sending them to Cassini that will relay them to Earth. Now, the Huygens probe is probably one of the coolest things that happened in human space exploration in the last decade or so, because it was able to shoot an actual video and the sound of the landing to Titan, and it was able to keep shooting pictures until its battery ran out of juice, basically. So this was actually one of the coolest missions, I think, because Titan is a really awesome object, and through this mission we were able to discover that Titan has very thick atmosphere. It has a liquid cycle on its surface. It has methane and ethane oceans, and a lot of other awesome stuff as well. And so here goes Huygens probe, and it's going to be basically landing on Titan any second now. And this is happening on January 14th of 2005, so for me that was only about 12 years ago, and boom, done. So it landed, took some photos, sent them to Cassini, and we relayed them back to Earth. Now, a few other events that occurred here that are not actually mentioned in this particular simulation is that we also discovered quite a lot of new moons and new satellites around Saturn. Now, the first one was actually discovered back in 2004, and I don't know if we can actually see it here, but we can see it in Universe Sandbox. So this moon right here, known as Methony, I believe that's how you pronounce it. Don't take my word for it. It's a Greek character that I'm not familiar with. This was actually one of the first discovered back in 2004. We also discovered these two on the same date, or very close to that date of 2004, so Pallene and Polydeuces as well. And these were the first three satellites that were uncovered using the new probe. Then in 2005, we also discovered this one right here, right next to the inner ring. This one was called Daphne. Then in 2007, we found this one called Anthe. And finally, or actually not finally, the sixth one was in 2009, this right here. This was Aegean, so all of them are kind of very close to each other. And the last one still has no name, or just basically has only a numerical designation. And also, unfortunately, I think it's not really represented in Universe Sandbox because I can't seem to find it. But if it is there, I just couldn't find it. It's definitely a smaller moon that is a lot less important than these other moons I just mentioned. But anyway, so let's go back to NASA's ICE, and we're going to be talking about one of the more important discoveries here. So of course we discovered the lakes on Titan using Cassini, and most importantly is we actually discovered something on Enceladus, and you're going to see it in a few seconds. We discovered that Enceladus, a much smaller moon of Saturn, it's about under 400 kilometers in radius, seems to have these really beautiful geysers, these eruptions of water and water ice from its surface that you're going to see when I zoom into it. What we found out about it is that, well, very recently actually, is that this particular moon may actually have necessary conditions for life on the inside. So let me just slow this down for a second. And we're going to go to Enceladus and take a look at its bottom. So these right here were discovered a few years ago, but specifically now we actually know that there's a lot of really cool stuff coming out of them, including molecular hydrogen that is often needed on Earth to power quite a lot of life. So inside of this is something known as hydrothermal vents. These really hot geyser-like environments create conditions for life. So we think that this might be actually currently the best place for us to find life outside of planet Earth. And because of this, we don't want to contaminate this. We don't want to contaminate this or Titan. So this is why we decided that the finale of this mission, when it occurs in September of 2017, is actually going to be a big crash into Saturn, while we're actually going to be transmitting various data coming from both Saturn rings and Saturn upper atmosphere. So all of this will happen in September 2017, and it will basically be a really cool mission to observe and to follow, because well, first we're doing this so that we don't actually contaminate those objects, and if we do find life, it's going to be a life from those objects, not a life from Earth that possibly is currently taking a ride on Cassini. And two is that we actually want to learn more about the atmosphere of Saturn, so this will allow us to do all of this. And once again, we're doing this because we're technically running out of fuel on Cassini, so it's going to be doing these proximal orbits that are going to be kind of like flying like this around Saturn and taking quite a lot of photos at the same time, a lot of observational data. And this will happen something like 34 times, I believe, and then final transmission will occur as it essentially falls toward Saturn. And this is actually speed of light in real time as it approaches Earth. And it takes about an hour to reach Earth, as a matter of fact. And so by the time that Cassini probe crashes onto Saturn, an hour later, we'll be able to finally get the data and the pictures and all of that stuff that basically arrives to Earth an hour after Cassini crashes into Saturn. And so that's basically the history and the essence of this mission. And if you want to know more about this, do check out NASA's ICE. It's a free app that you can use to, for example, go through various awesome photos. Like one of the most incredible photos on Saturn was actually taken. Also, yeah, this is what we found on Enceladus. But one of the most incredible photos is this: the day the Earth smiled. So this is actually what it kind of looks like. This is a photo that was taken with Sun sort of behind Saturn, and it illuminated Saturn's rings in this very beautiful formation. And so all of these are available for you to explore, including the storm that we found on Saturn back in, I believe this was 2010, and a lot of other really cool features. So there's a lot of information here in this app, but I kind of decided to just mention the important facts and important features. Hello wonderful person, this is Anton, and in today's video we're going to be talking about Cassini mission, but specifically about the discovery that was announced by NASA in April of 2017 in regards to one of the moons of Saturn known as Enceladus. And the exciting news was that we now think that there's a slight possibility, or possibly maybe even bigger possibility, that Enceladus might actually have life on it. So in today's video we're going to be using several simulations, including Space Engine and another one known as NASA's ICE, and we're going to be looking at this tiny dot that we're coming toward, that we actually just missed a second ago. This tiny dot right here, known as Enceladus. This is one of the moons of Saturn, and it's essentially a frozen world. It's a tiny frozen world that doesn't look very tiny, but it's actually relatively small. Its diameter is less than 500 kilometers, and it's basically maybe size of England, United Kingdom. Basically, here's actually what the comparison of Enceladus, Moon, and Earth looks like. This right here is Enceladus. It's not very big. It's actually really small. Now, we're going to be talking about this object from a more scientific perspective, and we're going to just make some assumptions, but not a lot. So let's actually start with the discoveries and how they were made. I'm going to use NASA's ICE for this. And this is a free simulation that you can download directly from NASA. And so here I'm going to go into one of the mission events. I believe we're going to go into this one, Discovery at Enceladus. Now this is a pretty awesome visualization of what actually occurred there. And so here's Cassini approaching Saturn. And so right now you can actually kind of see what's going to happen. During the flyby of Enceladus, it flew by these plumes that you can't really see here, but you might be able to see them when I actually zoom in a little bit better, that were formed by various geysers and various eruptions from within Enceladus. Now, we're going to wait for another simulation here that might actually demonstrate this a little bit better. And Cassini did this several times and eventually was able to actually detect some of the very interesting molecules, including things like salt, specifically water salt that we often have in our own water. And very recently, specifically in April of 2017, we were able to actually finally discover what's known as molecular hydrogen, which is actually kind of interesting. So let's actually go to Enceladus for a second. I'm going to show you what those plumes actually look like first. So we're going to zoom into Enceladus right now. And we're going to take a look at this site. So there are those plumes that basically the Cassini mission flew through. So it went about 14 kilometers away from them, and so it was able to detect some of the molecular hydrogen and some of the salt that was coming out of here. And today we know that there's actually quite a lot of these on Enceladus, and possibly even other so-called ice moons or water worlds, basically moons like Ganymede, Callisto, Europa, where on the outside you have a very thick layer of ice, and on the inside you very likely will have liquid ocean. And the liquid ocean on Europa is basically even bigger than the one on Earth, same with Ganymede. But here the ocean is smaller than on Earth, but it nevertheless very likely has something hot on the inside that produces these geysers, these eruptions. And despite the temperature on the outside being something like minus 200 degrees Celsius, because this is actually one of the most reflective objects in our solar system, it doesn't really get much heat from the sun. The inside of this moon is very likely much hotter, much warmer. And we think that this is because of things like tidal effects from nearby moons, like, for example, Dione. So if I were to zoom out here, you would see that every time Enceladus orbits close to Dione, which is right there, it receives quite a lot of tidal friction, and that sort of hits up the inside of this moon. And I think it's actually a little bit easier to see if I go to Space Engine, zoom out, and show you the orbits of all of the moons, and basically show you Dione, which is right here, and also Enceladus, which is right here. And if we accelerate time here, you'll see that they actually once in a while kind of pass relatively close to each other, and because of that, Enceladus gets quite a lot of friction and tidal effects, which often causes the inside of this moon to get heated up and thus produce all of these geysers. And these geysers are also responsible for one more thing. They're responsible for one of the rings of Saturn. Specifically, here's actually a better picture of it, specifically the E-ring. So this is the E-ring, and this is Enceladus. That's basically right inside of it. And we know that E-ring gets replenished by Enceladus's eruptions and essentially creates this very large, very beautiful ring around Saturn that's not as easily seen, but is still there nevertheless. And, well, okay, so why exactly is this exciting in terms of findings? Why are we talking about these geysers? Why are we talking about this molecular hydrogen? Well, there's actually two reasons. One of the reasons is because we actually have something very similar happening on our own planet Earth. We don't have these, of course, but we have something similar to these that produces similar materials. Specifically, I'm talking about hydrothermal vents. So this is what we think is happening on the inside of Enceladus. This is actually a video from Bremen University. And what's interesting here is that we think that these particular heated objects, these hydrothermal vents, are basically everywhere on the inside of Enceladus. And because we've detected molecular hydrogen, we know for a fact that molecular hydrogen is also used on our own planet Earth in these particular conditions to create all sorts of life. And molecular life, specifically microbiotic life, needs molecular hydrogen to create energy. And then bigger creatures, like for example these lobsters, will eat those bacteria, and bigger creatures will eat those lobsters, and so on. So these hydrothermal vents on our planet Earth create huge, tremendous communities of incredible life. And all of this is underneath, thousands of meters of water in complete darkness. So right now this is like 1,500 meters. All of this in areas where you wouldn't expect to find so much life, but it is there. And it's absolutely beautiful. And so if this is possible on Earth and all of the conditions for life are also present right here on Enceladus, so why would we not be able to find it there? So this is actually what we think might be happening. We might be actually able to find all of this incredible life underneath all of this ice shell and potentially discover similar conditions with similar crazy oases of life underneath all of this ice stuff. Now, interestingly, we do have one mission at least that could potentially look for this life, and this is a mission proposed by the scientists of European Space Agency, and I believe the mission is actually just simply called Enceladus Life Exploration. And it's a very simple mission. It's basically a probe that would orbit around Enceladus several times and try to catch as many of these molecules as it can, and then analyze them for potential signs of life. So we wouldn't even have to go on the inside to find signs of life. And if we do find signs of life, then, this is a sort of an indication that we might need to come here and bring some kind of a digging apparatus and go inside and find that life. So that mission might actually launch sometime after 2020 if it passes the initial proposal, and it would very likely take something like 5 to 6 years to finally with confidence say whether there is life on Enceladus or not. And all of this is because we've actually detected this molecular hydrogen very recently, and because we know that on Earth it's required for certain types of life in those hydrothermal vents. And this is actually based on the idea of methagenesis, a reaction that sustains microbial life in complete darkness underneath the ocean in environments where you wouldn't really expect to find life at all. So there might be metagenesis right here on Enceladus, and that means that there might be life. And of course, if we find life here, then maybe, just maybe, since Enceladus is very similar to some of the other planets, we might, not planets, but moons, we might be able to also discover something similar on Jupiter's moons. And here we're talking about Europa, which also looks very, very similar to Enceladus. Basically an ice world with a very large ocean on the inside, and its neighbors, Callisto, which is right there. A very beautiful object as well, and of course the largest moon in our solar system, Ganymede, which is right here as well. This is an object that's possibly a mixture of ice and rock and stuff, and so this might also have a very large ocean underneath. Now, all of this gives us a lot of promise for finding life outside of our planet Earth, and so all of these findings will hopefully be an indication that there's definitely a possibility for life outside of our planet Earth, even if it's just microbial life. And all of this gives us sort of a lot of hope that maybe, just maybe, Earth is not the only place in our solar system where life has took hold. So maybe, just maybe, other moons around our solar system will actually also potentially have life. And before we finish this video, let's actually use Universe Sandbox for one particular experiment that I wanted to try for a long time and still haven't tried. Let's actually, well, first of all, this is more of a size comparison between Enceladus and the Earth, but in more visual / more practical approach. But basically, we're going to launch Enceladus at Earth, and we'll see how big it is in comparison, but also what's going to happen if Enceladus actually does crash, if it does crash on the planet Earth. So look how tiny it is. It is a ridiculously small ball. It is actually a lot smaller than you can even imagine. It's basically smaller than most countries on our planet Earth. And like I said before, it's about the size of the United Kingdom. But if it does crash on planet Earth, yeah, things will not go well for us. Things will definitely not go well for us. And anyway, so maybe just maybe, this is how life did come on Earth a long time ago. Or maybe this is how life from Earth came to other moons and other planets in our solar system. But for all we know, hopefully one day we'll find life in our solar system on other planets and discover if there's other microbial and bacterial life out there. And one more time, this is actually what Enceladus looks like in comparison to our planet Earth. This is how tiny it is. Hello wonderful person, this is Anton, and this is Jupiter and Saturn. In today's video I actually wanted to discuss a very interesting hypothesis / theory that focuses on the fact that both of these planets have different number of very large satellites. Jupiter seems to have a lot more. It has 4 large satellites known as Io, Ganymede, Callisto, and Europa, whereas Saturn only has 1 known as Titan. And there is actually a very interesting reason for this. In today's video you're going to find out why, and hopefully you're going to learn something new. And so, as I mentioned, Saturn seems to only have 1 large satellite known as Titan, which is basically the second largest moon in our solar system, slightly larger than our own moon. If I were to place moon here, it would actually be a little bit smaller, and slightly smaller than Ganymede. So, there's only 1 of these though. Jupiter, on the other hand, has 4 of these large moons, and they're basically right here. There's Io, which is actually relatively large at about 1.2 sizes of or masses of our own moon. There's Europa. There is Ganymede, which is the largest satellite we have in our solar system, that is actually even bigger than Mercury. And finally we have Callisto. So if we were to look at the chart here, there they are, these 4 very large satellites known as Galilean moons, much larger than the closest moon to them. Now, why is it that Jupiter has 4 and Saturn has 1? For the longest time, scientists thought, well, maybe it's actually because Jupiter is technically more massive than Saturn, and because it had a lot more mass when it was forming, and so it got to create more satellites. This is Saturn for comparison. It's about 3 times less massive than Jupiter. But the reality is actually a little bit more tricky than that, and the reality has to do with the actual formation of these planets early in the formation of the solar system. So when they were still part of the protoplanetary disk, which you can kind of see represented by these yellow particles everywhere here, both Jupiter and Saturn were basically part of their own protoplanetary system where there was actually a disk orbiting around them. So let's just actually take a look at Saturn. And so here is a kind of a protoplanetary disk, or I guess planetary disk, orbiting around Saturn, which will eventually result in formation of various moons. Now, both Saturn and Jupiter had these, but the thing about Jupiter is that since it's more massive, it was able to collect, or I guess suck up, a much larger protoplanetary disk, thus clearing a much larger area than did Saturn. So this is what the Jupiter's protoplanetary disk looks like. Or I guess in this case it would be called proto-moon or proto-satellite disk. And this is a slightly smaller disk of Saturn. And because Saturn is slightly less massive than Jupiter, it wasn't actually able to clear this area of protoplanetary disk around the Sun as quickly as Jupiter, and so it couldn't actually collect as much material as fast. Jupiter, however, cleared this area really fast and started to coalesce its satellites, and at some point it basically started to look very similar to how it looks today. So here I just placed 5 random moons orbiting around Jupiter, and these 5 moons were created from this proto-satellite disk and basically started to kind of slow down because of all this material flying around Jupiter. But because Jupiter is so massive, it was actually able to clear all of this stuff very quickly, and so these moons didn't really get to slow down as much. Maybe some of them actually disappeared and some of them crashed into Jupiter, but the majority of the big moons kind of just stayed in the same area. So because of the actual mass of Jupiter, this area was cleared very quickly, and all of this proto-satellite stuff kind of just disappeared. However, in case of Saturn, these large moons that were formed from all of this material ended up not really getting the same sort of treatment because a lot of this material didn't disappear as quickly. Saturn was not as, or is not as massive as Jupiter, and so proto-satellite ring stayed here much longer. And because of this ring, these moons actually started to slow down over time. So I'm going to simulate this by basically literally slowing down this moon and manually changing its velocity. Now let's actually just see what happens to it as we pretend to slow down as it passes through through all of this material and through all of this stuff that's orbiting around Saturn. And there you go, it basically collided with Saturn. And so all of the large moons that were present around Saturn in the beginning ended up colliding with it, except for Titan. Titan was lucky enough to be far away and could actually wait long enough for all of the other moons to basically either disturb the proto-satellite disk or essentially collide with Saturn. And by the time Saturn finished forming its moons, and by the time the proto-satellite disk completely disappeared, which we're going to do right now by erasing all of these particles, Titan was already in a relatively stable orbit around Saturn, with all of the other smaller moons orbiting around it. Now, so this is essentially the very interesting explanation for why Saturn only has one large moon, whereas Jupiter has 4, Io, Ganymede, Europa, and Callisto. And this also explains why Ganymede also happens to be a little bit closer to Jupiter than other satellites, because it's more massive, it's actually larger, so it would have been affected by this proto-satellite disk a lot more than moons that are slightly less massive and are farther away. In other words, one of the reasons why Ganymede is so much closer to Jupiter than other moons is because it actually got affected by these tiny proto-satellite particles that used to exist here, and that basically slowed it down and made it approach Jupiter closer. And had it actually stayed around longer, in other words, if the proto-satellite disk was a little bit more massive or stayed around in the system longer, all of these moons would have actually also collided with Jupiter and would have actually completely disappeared, and it would have no large moons whatsoever, only smaller moons that it has today. And so just to summarize, the only reason that Jupiter has 4 large moons and Saturn only has 1 is because of the early proto-satellite disk that essentially slowed down all of these other moons and made them collide with its parent body. And so had Ganymede stayed around the proto-satellite disk a little bit longer, and had it actually decreased its speed even less, it would have actually very likely collided with Jupiter as well and combined with it. But as we have it, it just so happens that Jupiter was actually massive enough to get rid of this proto-satellite disk relatively early, and this actually saved its large Galilean moons from complete and utter destruction that you're about to see as I collide this beautiful and extremely large moon called Ganymede with the largest planet in our solar system, known as Jupiter. And there's actually the shadow of Ganymede approaching Jupiter, and here we go, here comes the collision. So this is what would have happened had the proto-satellite disk remained. Hello wonderful person, this is Anton, and in today's video I wanted to answer a simple question. How was this beautiful gas giant known as Saturn created, and how were its rings made as well? In today's video we're going to use Universe Sandbox to basically create Saturn from scratch and try to recreate this beautiful gas giant and its moons as well. And all of this started billions of years ago, specifically about 4.5 billion years ago, when the protoplanetary disk around our sun was still kind of developing and creating all of these planets, including planets like Mercury, Venus, Earth, Jupiter, and of course Saturn, which is right there. And so back then, the actual gas giant was still developing, it was still kind of floating through space. And as it was actually floating through space around our sun, it was collecting all of these dust particles from the protoplanetary disk and basically acquiring them in its own orbit. So a lot of these yellow particles that you see, became the blue particles here. This is of course just for the visual representation. And as it basically flew and orbited around the sun, it collected more and more of this dust until essentially we had something that looked like this, possibly even thicker than this. So I'm gonna maybe add a little bit more here. Basically, it was a very, very large planetary disk with a very central sort of region that would become Saturn. And this was basically all of the gas that collected into this one large object. And around it, there were quite a lot of various gases and quite a lot of various rocks just orbiting around. With time, though, these rocks and these gases started to coalesce into larger and larger objects, and so we're going to represent this by adding a few objects here to basically represent the potential moons that will be orbiting around Saturn in the near future. So there's a few moons there that basically represent larger rocks that coalesced into big pieces that started to basically orbit in various spaces, various regions of space around Saturn. Now with time, all of these objects will start becoming bigger and bigger. They'll actually essentially get rid of all of this dust around Saturn. They'll most likely interact with one another, and they'll most likely crash into one another, or possibly crash into Saturn, and essentially erase a lot of this interstellar, or not interstellar, but this planetary particle stuff that is currently orbiting around Saturn. So we're going to wait a little bit, let them interact with one another, and see what happens in a few weeks' time. So right after a few weeks, you'll notice that a lot of this dust will most likely get kicked out, and many of these moons will actually start combining into one another. Now, this process will not actually take very long. As a matter of fact, this will take less than a few million years to basically get rid of most of this material and to combine all of these rocks into large moon-like objects. And these will eventually become satellites. You may have actually just noticed a collision right there. There was a very large collision between two moons that I already missed. I don't know where they are. But basically, a lot of these moons will become proto-satellites and proto-moons of Saturn. Unfortunately, not many of them will actually stay here. Not many of them will survive. Because as they interact with one another and as they interact with all of these dust particles, they will eventually slow down and crash into Saturn. So most of them will actually not stay here. So millions of years will pass, and we're going to accelerate time here just to kind of simulate this. And most of this stuff will actually be gone. It will either be kicked out into the outer solar system, or combine into the moons of Saturn and then possibly crash into Saturn itself. So the majority of this stuff will very likely just kind of combine into the actual gas giant. And so you may have noticed that there's a lot of particles that are basically being thrown out by the more massive moons, and a lot of various moons are actually combining into one. So we're going to actually see this better when we look at their orbits. So right now, if I actually look from the top here, you'll notice that a lot of these moons are actually interacting with one another at all times. So right here, there's actually two moons that are very, very close, and they might even crash into one another any second. Even though they technically kind of look like the moons orbiting around Earth, they would not look like this in reality, of course. And less than a year later, you can see that a lot of the material has actually already escaped into the outer Saturn system and basically will never come back. And the moons are still kind of changing their orbits, they're interacting with one another, and they're actually slowly losing speed and will eventually crash into Saturn. And the reason they're losing speed is actually because they're interacting with various particles and with one another, and are slowly dragging each other down, basically reducing the orbital velocity. And so for the most part, most of this will be gone within the next few million years. So we're actually going to just erase the particles and leave just the moons. Now let's accelerate time and let's just have them interact with one another until there's basically almost nothing left. Now, most of these moons will combine with Saturn. They'll actually crash into Saturn and they'll become part of it. But there might be some moons that will be left. In reality, we know that it's very likely that only Titan was left from that time, and you can kind of see that just for a second there, Saturn actually lit up and it became very bright. That's because something just crashed into it. One of the moons just crashed into it. But yeah, so only Titan very likely remained from those days back in the beginning of the creation of Saturn, and possibly some of the other larger moons, but there you go again. But definitely not the smaller moons that we currently have orbiting around it. And so we're going to run this for a few years until there's almost nothing left, and until there's just a few large moons remain. So let's just accelerate time here and watch what happens. And just around this time, you notice that there's suddenly all these colors here. That's because something just fragmentized, became fragmented, and basically started orbiting around Saturn instead of being a whole chunk. Now we're still losing some moons, but there's still quite a lot left, so it will take maybe a few more years before we finally lose most of them. So I'm going to just wait a little bit and let the game interact and let the objects crash into each other until there's almost nothing left. And so here we are 60 years, or 60 in-game years later, and we've lost quite a lot of these satellites. As the years progress, we'll lose more and more of them will most likely collide with Saturn and completely disappear. So what we'll have at the end is going to look something like this. There's going to be a bunch of moons left in the orbit around Saturn, with Titan somewhere on the outskirts, and Titan here would probably be the largest moon currently available. The other moons would be pretty large as well, but what will happen to them eventually is that they're actually going to crash into Saturn, and this is because there's still a little bit of planetary debris left orbiting around Saturn, and as it orbits around, it's going to slow down all of these objects, and they're slowly going to basically crash. So let's maybe accelerate time just a little bit and pretend that this happened a lot sooner than it would otherwise. So a lot of these moons are basically now going to combine with Saturn and become part of it. So there you go, there are the crashes, with Titan being the last. Now, some of the smaller moons will very likely remain in orbit as well, because they wouldn't have as many drag effects from the particles orbiting around Saturn. And so at the end, we'll get something that will very likely resemble the Saturn that we know today, with all of the smaller moons present and Titan orbiting right around here as well. There's still one thing missing though, the rings. Where are the rings? Well, as Saturn orbited around the solar system, it started capturing various asteroids, and this is actually what these irregular satellites around Saturn are. Every single one of them is actually a captured asteroid from either the asteroid belt or possibly a comet that approached closer to the Sun. But some of them got to actually orbit around Saturn relatively close, or maybe even passed by really close to Saturn, like within vicinity of its Roche limit, which would essentially destroy these comets. Alright, so these ones are actually going to crash into Saturn, so that didn't work as well as I planned, but let's actually try to launch one this way and see if it actually is going to work. And there you go. So there is Charuklo that passed by, maybe a little bit too fast. We can try this again actually, maybe a little bit slower this time. And there we go, but still not exactly the orbit I was hoping for, so maybe we'll just have to put them in orbit, manually put them in orbit just to see what's going to happen. So if an asteroid approaches Saturn, or really any gas giant relatively close, and this is exactly what happened, they're going to basically disintegrate, as you can see right now, and create the actual rings around Saturn. So with time, it captured quite a lot of various asteroids that essentially we're going to use right now to create a manually made asteroid ring around Saturn, because the Roche limit or the tidal effects of Saturn are going to destroy these asteroids. It's going to completely disintegrate them into little pieces like you see right here. It's going to be little fragments that will eventually become nothing but tiny rings that we're going to be creating right here. And so with time, what happened was that all of these asteroids that Saturn was able to capture, these were mostly containing ices and things like water. All of these basically created the beautiful rings that we have around Saturn today. So Saturn is full of mysteries, and as Cassini showed, there's a lot more mysteries here than one mission can possibly discover. And one of those mysteries is, of course, the fact that we don't even know how many moons there are around Saturn. As a matter of fact, one of the first mysteries here is in regards to us finding a new moon being created right here in Saturn rings. Now, it's kind of difficult to see them right now. I'm going to see if I can actually maybe create them a little bit better by adding slightly more particles for rings. And so we know that these rings change quite a lot, mostly due to interaction with other moons and other objects in the system here. But what Cassini saw was actually something unusual. It actually saw a very unusual band in the ring system that stayed there for quite a while, and we later realized that it's very likely that this band was actually formed by a newly created moon. Now, we don't really know where this moon is located just yet, and we actually haven't seen it or taken a picture of it, but we have been able to calculate potential size and mass of that moon based on the amount of gravitational interaction it had with the rings, and we actually even have an unofficial name for it. Okay, it's more of a nickname. It's known as Peggy. And there's Peggy right there. It's just kind of randomly created, but basically it's a rock. It's a moon that's about 2.5 kilometers in diameter, and this would make it the 63rd moon of Saturn if we actually take a look at it and are able to discover it in a telescope. But since Cassini is no longer there to look for it for us, Hubble might not actually be able to see it because it's a little bit too small and we are a little bit too far away from Saturn. But we know that it's there, and it's somewhere inside Saturn A ring. So for all we know, there's now 63 moons of Saturn. The other unusual discovery is in regards to another moon of Saturn known as Hyperion. And Hyperion, if I look around for it, is actually located right on the outskirts of the system. Now, the interesting thing about Hyperion, other than of course its shape, it has a very elongated shape, is that when Cassini passed by Hyperion, it basically flew by, and we can demonstrate this by doing the following. So there's our Cassini craft passing by Hyperion. So as it passed by, it actually experienced quite a lot of hydrostatic electricity. Basically the same kind of electricity you get from rubbing your feet on the carpet and then trying to zap someone. But the zapping here was obviously much stronger. We actually do get hydrostatic electricity on our own moon as well, and a lot of spacecraft that land in there get zapped, and we have to be very careful with it. But that's because moon is actually very dry and is exposed to solar charged particles all the time. And this is probably the same reason why Hyperion is also charged, or why it also has electrostatic charge. So studying moons like Hyperion and our own moon, we'll be able to understand this hydrostatic electricity in a little bit more detail, but most importantly, we might be able to learn how to use this for potential power in the future, and maybe even find out how we can use this to discover other things, like for example, using the electromagnetic map of the hydrostatic electricity to map the actual moon. Well, maybe all of this will be in the future. We don't really know yet. So that's unusual discovery number 2. Unusual discovery number 3 is the Saturn itself. And so here, I'm going to see if we actually have it in Universe Sandbox. So we know that Saturn has a very unusual, very strange looking hexagonal shaped storm that's formed on one of its polar sides. Now, this is not a really good representation of it. A much better representation is actually from the picture itself. But let me actually show you how we think it was formed. So some people actually started speculating that this was the reason why there were aliens on Saturn, or maybe it was an artificial structure. And here's actually kind of a similar shape that's already formed here, but the actual reason for the formation of that shape is completely natural. So if you have winds moving around the planet in the polar region, and they're moving around a very large sort of circumference, and here it's actually basically the size of Earth. This is the size of Earth. It's about 32,000 kilometers across. you'll notice that they actually start forming these very beautiful symmetrical patterns. So right now it kind of looks like a flower. If I kind of roll it for a few more days, it's going to change into something else. And eventually it will settle for the most stable shape, which is actually going to be a hexagon. So right now it's slightly different flower. And Universe Sandbox is really good at simulating this. And basically, as you run this longer and longer, it will get more hexagonal and more like the actual thing, which is very, very cool. When I found out that Universe Sandbox can actually do that, I was really, really pleasantly surprised. So you don't always get hexagons right away, but with time you usually do. So this unusual formation, this unusual hexagon on Saturn is actually a physical interaction of winds across a very large area in the polar region, and this creates the unusual hexagon shape that we see there. Alright, so that's unusual discovery number 3. And unusual discovery number 4, and I guess unusual discovery number 5 are actually on the same object. And as you probably guessed, this object is Titan, the second largest moon in our solar system, the moon that's even larger than Mercury. Now, first mystery here, first unusual discovery is in regards to this beautiful moon actually having water. So it's not all methane and ethane. There is actually water on it. Okay, not on it, in it. Underneath the surface ice, underneath the water ice, there is liquid oceans. And these liquid oceans are very likely still there today, and are very likely are slowly growing smaller and smaller because this moon is losing heat. And as it loses heat, the water inside freezes. We can maybe make it a little bit more dramatic just so you can understand better. The water inside of this freezes, increasing the rigidity of the moon and increasing its actual size, because as water freezes, the moon expands. And basically, at some point, it's going to freeze completely. But as it freezes, the methane inside of the moon gets released into the atmosphere and kind of stays there. And one of the reasons why there is so much methane in the atmosphere of Titan, basically it's mostly methane, is essentially because it all got released from inside of the moon over time. It used to be stored in ices and other components, and then it got turned into atmosphere by the essentially freezing of the water and the ocean inside Titan. And this ocean is very likely very, very salty, kind of similar to what we have here on Earth in Dead Sea. It's super, super salty ocean water. But with time, it will actually disappear. It will become completely frozen over and turn into ice essentially. And this will remain as a methane and ethane planet, or not planet, but moon. And it will be a very interesting world to visit for sure, but we don't really have any plans anytime soon. And the last unusual discovery is also here, and that's in regards to the, I guess, weather on Titan. And the weather on Titan is just weird. It's kind of always very similar. The weather here is pretty much always raining, 100% humidity, but humidity here represents, or is represented by methane. So there's always a drizzle of methane droplets, and you'll always need to have an umbrella. But obviously the temperatures here are a little bit chilly. It's about minus 183 degrees Celsius. And so the rain is very, very cold. So you do need to bring a very warm rain jacket and very warm rain boots. But also you might want to bring an oxygen tank. But you don't have to bring in a spacesuit because this planet has a lot of atmospheric pressure. So these are the 5 main unusual things we discovered about Titan from the Cassini mission, and from Huygens' mission that landed on Titan. And so these are the 5 unusual and very, very cool discoveries from the Cassini mission that visited Saturn. The mission that started 20 years ago for me, basically back in 1997, and that ended with a beautiful crash into the Saturn's atmosphere. So these 5 unusual discoveries will hopefully help us understand the universe a little bit better, and maybe one day we'll go back here and even colonize Saturn, because that would be super, super cool.